eFest is a giant engineering festival. It's a chance for the engineering communities to come together, compete against each other in different competitions.
For the students, it should be a lot of fun, a lot of partying, while they're also learning a lot about technology.
HPVC by far is the most energetic and the most involved with all the students. I think it's the best part of eFest so far.
So this is it, the final round of the student design competition, robot football. It's all led to this point.
You guys' robots look amazing. Everything falling off of other robots, you guys stacked them on there real well.
I guess what's next for us is just to really try to win this race. This is our senior year and we'll never probably get to be in college with this experience again.
Some of these other elements that some of these teams have, very interesting, hard to compete against, but made for a good competition.
Absolutely.
eFest provides terrific opportunities everywhere. Every student that's here has a different story to tell, and certainly we can't tell every one of those stories.
eFest Digital.
Hello everyone, and welcome to eFest Digital. I'm Tom Costabile, ASME's Executive Director and CEO. I want to thank all of you for participating in this inaugural virtual event. Reflecting for a moment on what's happening in the world today with the COVID virus, we want to be sure that everyone remains healthy and safe during these challenging times. On behalf of ASME, we extend our best wishes to all. ASME is excited to host this online event because it allows us, no matter the distance, to engage with a broad community of engineers just like everyone here. We are very pleased to be able to welcome those of you that have been members of ASME for a long time, as well as those of you who are new to ASME. Welcome and enjoy. I look forward to seeing all of your video submissions and will be following you closely on ASME's YouTube channel. Best of luck to all our participants. Have fun, be safe, and enjoy.
Hi, I'm Erin Dolan. I'm a program manager here at ASME, and for the last 3 years, I've been lucky enough to be part of ASME's eFest program. You just heard from Tom Costabile, ASME's Executive Director and CEO. We're grateful for his support and encouragement throughout this planning process. We know that many of you are disappointed in not being able to participate in the traditional in-person eFest, and we are too. But we wanted to give you a platform to be able to showcase the creative work you've been doing throughout the year. So we're excited to introduce a new event to the eFest portfolio, and you're all part of it. Welcome to eFest Digital. Throughout the day today, you'll hear from a number of different staff and volunteers, as well as our corporate sponsors. We hope this gives you some insight into ASME and how you can stay involved with us throughout your student and early career lives. You will also have the opportunity to see many video submissions for our eFest competitions. Those videos will be located on their respective playlists here on the eFest YouTube channel. We'll be making announcements throughout the course of the day that lets you know which videos are being launched on which playlists. The winners of those competitions will be announced at the very end of the day in our virtual closing ceremony. You can also refer to the program tab on the eFest Digital website for a broad overview of today's schedule. But stay with us here on the YouTube eFest channel as we'll be offering random quizzes and raffles along the way. Enjoy yourself and stay well. Thank you.
Hi, my name is Wendy Felton, and I'm the social media manager for ASME and ASME eFests. Make sure you're following us on all our accounts, Instagram, Facebook, Twitter, and LinkedIn, to get eFest updates, engineering news, career advice, and more. See you there.
Hey everyone, my name is Prakhardeep. I'm Manager Programs at ASME India. In late February, we conducted the largest eFest ever with more than 1600 attendees at Marwadi University. Isn't that exciting? We will be soon posting photos and videos from the event over our eFest global website, efest.asme.org. But in meantime, have a look on a short video compilation from the event.
Hello, my name is Sean Miller. I'm a section coordinator here at ASME, and the awesome team I am on supports the operations of the professional and student sections around the world. So if your section needs assistance with anything from development strategy to connecting with the other professional and student sections in your area, we are here for you to provide resources, tools, connections, and guidance. If you would like to be connected with the section coordinator for your region, please email me at millers2@asme.org. Now, stay tuned for a session by ASME's Student Leadership Training Team titled Creating Your Self-Brand.
Self-branding. You probably heard about it in interviews with celebrities and influencers. However, it is crucial for every person with high career goals and a long-term vision. Take Billie Eilish, for example, an 18-year-old pop star who's grown a 50 million fan base within 4 short years. But what are her branding secrets? Billie Eilish created a completely unique self-brand by adopting a consistent clothing style, the oversized matching tees and shorts, being authentic by writing songs about her own thoughts and interests, and portraying her true self, which makes it hard for competitors to copy. She spends her time connecting with her fans, while many celebrities focus on competition. Stay with us as we create a step-by-step guide to build your self-brand and enhance your relationship with your peers, family, co-workers, professors, and managers. Every one of us is unique, and in this session, we will help you highlight your own uniqueness. My name is Nicole, and I am leading the expansion strategy for the Student Leadership Training Committee. I have Maya with me in this session, and she is working on expanding our work to Europe. We organize a 3-day international professional development conference and conduct several regional workshops for ASME members every year. Just like branding any product or service, you must first understand the basic components or raw material that make up that product. The following steps will provide you with tools that allow you to identify every raw material that makes you, you. 6 pillars are the basis of every one of us, and the differences in these pillars make us who we are. These pillars are our strength, potential strength, bad habits, interests, personality, and core values. Everyone possesses 24 character strengths in different degrees, so each person has a truly unique character profile. In fact, the number of potential strength profiles is exponentially greater than the number of people living on our planet. When you know your strength, you can improve your life and thrive. Research reveals that people who use their strength a lot are 18 times more likely to be flourishing than those who do not use their strength. Each character strength falls under 6 broad virtue categories, which are universal across cultures and natures. Let's go over the strength grouped under every virtue. Starting with the virtue of wisdom. It includes creativity, curiosity, judgment, love of learning, and perspective. The strength under the virtue of courage are bravery, honesty, perseverance, and zest. Justice includes fairness, leadership, and teamwork. Moving to the virtue known as the virtue of temperance, it includes forgiveness, humility, prudence, and self-regulation. As for the virtue of transcendence, it can be illustrated by gratitude, hope, humor, spirituality, and the appreciation of beauty and excellence. Last but not least, we have the virtue of humanity, and it can be characterized by kindness, love, and social intelligence. There are multiple online resources where you could take a free online assessment and receive your character profile. Take viacharacter.org, for example. Keep in mind that what we presented so far does not give you a complete representation of your strength, so widen your thinking process by identifying other skills. You could look at knowledge-based skills, manual skills, job-specific skills, and transferable skills that you can take from job to job.
Many life coaches and personal trainers argue that focusing on your current strengths is the best way to improve yourself and build the most marketable personal brand. However, being aware about your potential strengths also defined as the skills that can possibly be good at if you put enough effort, time, and resources will help you improve in the areas that enable you to achieve your goals. To assess your potential strengths, look at your strength profile and check the ones that you have in lower degrees. So the questions you can ask yourself are the following. Which areas would you prefer to rate higher? And which strengths are necessary for you to achieve your goals? And finally, why are your potential strengths not your current strengths yet? Is it because of insufficient training or instruction? Or is it lack of opportunity and motivation? Typically, bad habits are not raw materials that you want to disclose to other people, especially not to a potential employer or investor. However, it's crucial for you to acknowledge them and understand them because they could easily overpower your set of strengths. It is important to acknowledge that habits are not a rooted thing, so if recognized, they can actually be changed. One of the ways to do that is to keep track of those habits by keeping a log or a schedule and writing them down. That's when you can notice your pattern and break them, and then eventually you can see the difference. For example, if you are the best in your company at designing 3D models, but you're always late at delivering your designs, eventually your employers will start to discount the value of your design skills because of the serious negative impacts of your bad habits. Here are a list of different bad habits that many of us relate to. Some of them are procrastination, laziness, impatience, disorganization, lack of focus, and many others. So to assess your bad habits, ask yourself, in what area of your life do you sometimes receive complaints or criticism? What attributes or habits seem to slow down your progress on tasks? And finally, what habits would you rather hide from others? This raw material seems simple, but it is very important to know exactly what your interests and desires are, because they are the essence of your motivation. Therefore, ask yourself these questions. What motivates you? What do you like to do? What do you enjoy? What inspires you? And finally, what drives you? Once you identify your interests, you can focus your efforts to improve yourself in these areas. Your picked interests, desires, passions will often relate to your personal and professional growth in one way or another. Not to mention that you will enjoy yourself while improving. According to the American Psychology Association, personality refers to individual differences in characteristic patterns of thinking, feeling, and behaving. The most common framework to identify different personality types is the Myers-Briggs Type Indicator. It provides a way to evaluate yourself on 4 different aspects that constitute your personality. The first point that this indicator tests is the favorite world. So do you prefer to focus on the outer world or on your inner world? This is basically called extroversion or introversion. 2. Information. Do you prefer to focus on the basic information you take in, or do you prefer to interpret and add meaning? This is called either sensing or intuition. Number 3 is decisions. So, when making decisions, do you prefer to first look at logic and consistency, or first look at the road and special circumstances? This is called thinking or feeling. Last but not least is structure. So in dealing with the outside world, do you prefer to get things decided, or do you prefer to stay open to new information and options? This is either called judging or perceiving. Therefore, when you decide on your preference in each category, you have your own personality type, which can be expressed as a code with 4 letters. You could also take an online free assessment that would give you the 4-letter code that corresponds to your personality, along with a detailed explanation of your personality type. This personality test increases your self-awareness significantly and helps you understand yourself and people around you. Core values are the guiding principles or the beliefs that would dictate your thoughts, emotions, and behaviors. They end up being the basis by which people judge their own actions. A complete identification of your core values would need a session on its own. However, we found it important to mention it because it is a fundamental, raw material that makes us who we really are and helps us in making important decisions. Keep in mind that core values can change over time. For example, due to life events, your involvement with other people and/or your exposure to different cultures might vary. So, you should revisit this assessment every year or two.
Now that we went through the 6 steps to create your self-brand, it's time to combine all raw materials together and come up with a few sentences that would define you. To do so, make sure you are answering 3 questions. Why do I do what I do? Defining your purpose in life. How am I doing it? Highlighting your strength. And what do I do? Mentioning your sector or profession. Answering these questions will guide you to introduce yourself in a comprehensive and concise manner. The more your daily habits, actions, and achievements are consistent with your raw materials, the stronger and more trivial your self-brand will be. We'd like to conclude with a quote by Brian Tracy that summarizes our session.
Your job is to do your job really well. Continually think every day how you can be better than you were yesterday.
We hope by now you understand the true value of self-branding, what a self-brand really is, and how to start building your own. We remain available via LinkedIn if you would like our one-on-one support with building your self-brand, or if you would like to know more about our future sessions. Thank you.
Hi, I'm Anne Marie Beck. I'm a Treasury Specialist in the ASME Finance Department.
And my name is John Beck, Manager of the Membership Department here at ASME. You guys may recognize me at prior IMECs or prior eFests. This year at ASME's Digital eFest, we'll be giving away 1,000 memberships for the first 1,000 non-members that register for eFest this year. Also, if you have any questions about membership, please reach out to me at beckj@asme.org.
Or for more information, you could also visit us at www.asme.org. Thank you.
Hi everyone, this is John Falcione, Senior Director of Media, Content, and Strategic Relationships here at ASME. One of my most favorite tasks is, however, being the Editor-in-Chief of Mechanical Engineering Magazine. I hope that you enjoy the magazine every month as much as we enjoy putting it together for you. As you know, we're all indoors today. You can see I have a little extra facial hair going, and I hope you're staying safe and sound and enjoying this first ever eFest digital event. Of course, we all enjoy seeing each other face to face, and one of the things that I enjoy most about eFest, and I've been going to every single one since day one, is getting an opportunity to interact with all of you face to face. But we'll do this again next year. We'll get together, we'll get an opportunity to chat and get to know each other and do all the things that we always do at eFest events that are on site. But I know that this year, and I hope you're enjoying it, we're presenting to you tremendous content, great workshops, great speakers, and overall great content. So I just want to say hello and introduce the next session, which is actually a sponsored event. So thank you to all of the sponsors who have helped put this eFest together, and also thanks to all of you for tuning in. We hope to talk to you later. Thanks. Bye.
Hello, digital eFesters. I'm sorry that we didn't get the opportunity to meet face-to-face this year, but I'm excited to have the opportunity to show you the revolutionary proprietary CAD technology from Siemens Digital Industry Software. It's called Solid Edge. And after seeing the introduction, I think you're going to agree with me that it's unlike anything else you've ever seen and possibly even used. Solid Edge uses a technology we call synchronous technology to remove the pitfalls and frustrations of traditional history-based CAD modeling. With Solid Edge, you no longer need to worry if you model the part correctly, so that when you make an edit, the downstream features won't fall apart and require tons of rework. Also, with synchronous technology, design intent can be changed on the fly. So let's take a quick look at Solid Edge. The first thing I think is important to understand is what is design intent. So let's open up just a very simple little block. And this was modeled with just 4 features. This is an ordered model, similar to all of our competitors. where it's feature on top of feature on top of feature. So in this part you can see how it was modeled. Let me turn off the dimensions here, and I'm going to do a go to. So I'm going to roll the model back to the very first feature. So there was a shape and it was extruded. The next thing that happened is there was a cutout added, and then a second cutout, and then the rounds were added. So at the time that this was created, what was important were the two cutouts relative to the rest of the part. So those were put in as features. But the problem is design intent can change. What if this part needs to be modified? What if this 75 dimension needs to change to 100? But the angle and the 35 need to be maintained. So really it just needs to add 25 millimeters of material off the back side of the part. What if this center piece needs to be taller or shorter by, say, 20 millimeters? What if this center piece needs to be 40 millimeters instead of 30? Well, the only way to do that in a history-based CAD tool is to go and take 5 from each of the cutouts to end up with a width of 40 in the middle, based on how it was modeled in ordered modeling. So let's go ahead and take a quick look at how we would change this model in a history-based CAD tool. So the first thing I need to do is roll back to the very first protrusion and go to its profile, and I want to make this 100. So if I just go ahead and change that to 100, notice that that 35 now changed to 60, and we said that that needed to be maintained. Also, that angle changed, so we don't want that. So let's undo, and we need to figure out why that's happening. Well, I see that I have a locked dimension of 40 here. Well, if this is going to add 25 here, it's also got to add 25 to this 40. So we need to unlock this dimension so it's free to move. Now we're ready. Let's go ahead and change that again. Still the same result. Why is that? Well, when this was modeled as a rectangle. It was centered on the coordinate system, and it created this relationship from the midpoint to the coordinate system. That's what's keeping that there and moving the other side. So that has to be removed. Now this is all design intent that was added, but not necessarily on purpose. It was just the way it was modeled. Now that's restricting us from making the edit that we want to make. So now we can go in, change that to 100, and now we got the result that we wanted. So we'll go ahead and accept that, let it recalculate the rest of the features. What happened here? Well, we have a cutout. Well, why does it not go all the way through? Well, because when this was modeled, whoever modeled this, for the extent step, they just clicked a point, which created a finite extent. And once the model got longer than that finite extent, it no longer cuts all the way through. So really the design intent should have been to go through both sides of the material forever using the through all instead of just clicking a point. That way it wouldn't matter if that got longer. So that was just an error in modeling at that point. Alright, so now let's move on. So we said that we wanted this centerpiece to be 40 millimeters wide. Well, the only way to fix that then is to change the cutouts. So we need to go to the first cutout and let's edit its profile. And remember, I said I need to take 5 off of that, but this is modeled from the center. So really I need to add 5 to that dimension and then subtract 5 from that dimension to keep the cutout, or to keep this leg the same width on the other side. So let's go ahead and accept that. And then we have to go edit the second cutout. This one was dimensioned differently. It's dimensioned from this edge. So we know that we want that to be 40. And again, we'll need to take 5 off of the cut to maintain the width of the other leg here. Alright, so that should do it. Okay, perfect. Alright, so we just had to do some calculating and figuring to get that to be the correct dimension. Now, we said that we want this centerpiece to be 20 millimeters taller. Well, that's a problem because it was modeled as a protrusion. So we're going to have to go and create maybe an extrude, and we'll go parallel off of this top face. We'll come up 20 millimeters, and basically then what we're going to have to do is just include or project these edges onto that plane, and then we need to trim those together. Alright, so that gives me a rectangle then that I can extrude down to the top of the other part. And we still need rounds. Alright, so we had to do some modeling there to get that the way that we wanted it. Now, what if you came back and told me, well, that needs to be 20 millimeters shorter, not taller? Now I'm going to have to go and create a cutout, cut the top of that off, re-round it, and so it's just a lot of work. And so that's just some of the demonstration of what design intent is. So let's look at how we could do this in Solid Edge using synchronous technology. So let's go ahead and close the model. I'm going to reopen the exact same model. And I'm going to move this to a proprietary tool that we have in Solid Edge called Synchronous. So I can just right click and I can take any model and move it to Synchronous. Okay, now that it's in synchronous mode, that means I can make whatever change I want wherever I want because I'm always changing the model. I'm not looking at how the model was built. I don't care what these features are. What do you want to change? Well, this dimension needs to change, and so I'm going to change that. You notice the blue face, that's the face that's going to move when I make a modification. So I'm going to key in 100, and it just does it. It doesn't care how the model was built. We also said that this needs to be 40. Well, I can just simply select that dimension. The arrow's pointing in both directions. So as I make a modification, you can see it's getting wider. It's making the cutout smaller. So we'll make that 40. Very simple, very easy. I don't care how the model was built. This needs to be taller. So as I click this arrow, I can pull this up. I can make it 20 millimeters taller. I can make it 20 millimeters shorter. Doesn't matter. Again, makes no difference how the model was built. So synchronous technology makes it completely flexible. Change whatever you want to change with your design intent. Maybe you want to maintain this 30, so I'm going to go ahead and lock that down. And now what happens when I change this and I want to make it wider, it's going to maintain that to always be 30. So as I'm changing this, also notice that it's changing the other side. We have this proprietary tool in Solid Edge called the Design Intent Manager. So when I click on a dimension, these are the geometric conditions within the part that it's going to try and maintain. One of those is symmetry. So it's seeing symmetry about the coordinate system, about the center of the part. And it's maintaining it for me automatically. So as I make a modification, it's keeping the part symmetric. Very, very powerful functionality. This next example is something I know you've all encountered before if you've ever used a history-based CAD tool. This model is a fuel tank from a lawn mowing machine, and you can see this is an ordered model also, so it's a history-based model. So there are a lot of features. And so the design change that is required is that this angle on the front be rotated out 15 degrees from this bottom corner. So the first issue I have is that I didn't model this part. So how do I know which feature needs to be edited? Well, you have to kind of guess. You got to touch the face and see what features are relative to that face. So I see that the first one that pops up here is this protrusion 10. So I'll go ahead and I'll edit that feature. And I see that is not the feature that is controlling that angle. So I'm just going to click escape. So I need to figure out which one it is. It's not the draft. Protrusion 1, looks like that's the shape. So how scary is it to roll the model back to the very first feature in the tree? So you see all these arrows, meaning it's rolling the model back to the profile of the very first feature. And we want to, we said we wanted to add 15 to that. Okay, and then once you add 15 degrees to that, you let it recalculate all of the downstream features. And how many of you have seen this issue? All of a sudden you have a lot of broken features. There were dependencies between the features, like we showed in the very first design intent block, where you had a dependency based on where things were and what it expected. And now I've got to spend hours and hours trying to figure out what I need to fix, what I need to change to get that model back in shape. And you know what? A lot of times it's just easier to start over because it becomes such a cobweb, such a mess of features. So let's close this file and let's see how we would do this with synchronous technology. So I'll open up the same model again. This time I'm going to take the last feature, move it to synchronous, which means it takes the feature that I selected and everything above it, moves it to synchronous, so now nothing is unordered. Synchronous means that there is no dependency. I can take protrusion 1, I can put it anywhere in this feature list, and it does not affect the model because it's not a recipe, it's not a history. The correct answer is the solid model. We don't care what features you use to get there. So how do you make an edit then if you're not editing a feature? Well, you edit the faces directly. What do you want to change? I want to rotate this face. We have this tool called the steering wheel. I'm going to put it right down here on the radius of the arc at the bottom. And then I click on the torus to initiate a rotation. And I want to rotate that face out 15 degrees. I don't have to worry about any of the rest of the model falling apart and breaking because I'm not editing features, I'm editing faces. What do you want to change? Does this face need to be deeper? Go ahead and push it deeper. Notice that those two faces were coplanar and it maintains it automatically. If you don't want that, it's just a matter of unchecking it. Now it's only going to move the face that I selected. Okay. You got two faces that need to be on the same plane. I want this face to be on the same plane as this face. I don't want to have to edit a feature to do that. We have some relate tools, and we actually have animated tooltips that show exactly what that command does. It takes one face and makes it coplanar to another face. So I'm going to take this face, accept it, and I want that face to be coplanar with this face. Just automatically does it, rerounds the part. Very, very powerful functionality with Solid Edge. Makes editing a breeze. Never having to worry about downstream features falling apart. So now that we've seen how we've taken some models that existed that were ordered, let's see how we actually model using synchronous technology. So I'm going to close this file and let's just start a new part file. I'm going to do an ANSI metric part template and we're just going to model something from scratch. I'm going to turn on my base reference planes. So you can think of these as pieces of paper to begin modeling. So you need to determine, are you sketching a front view or top view, right side view of the part that you want to model. So let's just say that we're going to be modeling on the front view. And I'm going to start with just a simple rectangle. So I'm going to use my rectangle by center command. I need to tell Solid Edge which piece of paper or which reference plane I'm drawing on. So when I highlight it, it shows an F3 lock, so I can click the F3 button or click on the icon. I'll know I'm locked onto that plane because it shows me an F3 in the upper right corner and highlights the plane. You can use the view cube to bring that normal to the screen, and let's just click on the point and begin creating a rectangle. I'm going to key an exact value, so I'm going to go 250 by 50, and it adds those dimensions for me automatically. I'll go ahead and turn off our reference plane now. Actually, let's go ahead and add a few more lines to make it a little bit more interesting. So I'm just going to continue, and you don't have to model normal to the screen, you can model at an angle so you can see what you're doing. Let's add one more line down here. Alright, so how synchronous technology works when you're modeling is you select one of these regions created by the profiles. So even though the lines overlap, it doesn't matter because it creates a region. So you can click on the region, don't even need to click a command. Simply click an arrow and you're immediately extruding it into a solid. Just tapping the shift key toggles between symmetry and not. Depending on which one I select, which I'm creating. If I want to revolve this, make it a round part, I just drag it to an edge, click on the torus to initiate a rotation, and now I'm making a round part. Now obviously depending on which edge you put it on, you can get completely different answers. Maybe you want it to have a hole in the middle. So we can move it down here, initiate our rotation, And you can see that we've drawn a profile that we're revolving around a center line. Alright, so let's just go back to the basics. Let's go back to the rectangle, and let's just extrude this rectangle. And what I want you to watch are the dimensions. So when I commit to a width, you're going to see those dimensions migrate from the sketch directly onto the solid. Because in Solid Edge, as I mentioned in Synchronous, you're never going back to that protrusion to make an edit. You select on the model exactly what you want to change. If I click that dimension, I can change that dimension right away, 400. The other way to do it is by actually selecting a face. So I can select a face and drag it. Notice again, it's seeing that a part is symmetric, it maintains it. If we don't want that, we just disable it, and it's only going to change the side that I selected. Let's go and draw another line. I'm going to draw a line on the top, so I'm going to lock onto that plane. I'm just going to draw a line across the top of the part, and that breaks that into regions. So I can click that region. If I push it into the part, it's going to cut it away. If I pull it up, it's going to add material. Very, very simple. Now if you just think about this for a minute, the way I modeled that is I extruded sideways and then I extruded straight up. So what I didn't think about is the possibility of wanting to have that vertical leg at some angle. So in a history-based model, I didn't model it correctly because I should have modeled it as an L shape where I could change the sketch profile angle to extrude it. Again, in Solid Edge, we don't care how you model it. What do you want to change? As a matter of fact, here is the original sketch. It does not match the model because we don't use the sketch. As a matter of fact, you can delete that sketch. If you try that in a history-based CAD tool, your model just went away because it relies on that sketch. So again, how do we change it? Solid Edge, select what you want to change. Take our steering wheel, move it to this bottom corner. That's where I want to pivot. I'll click the torus to initiate a rotation. And now as I move that, you can see that I can rotate that however I want to. And in this case, I'm going to rotate it back 30 degrees. You want to add an angle to the side? No problem. Let's go ahead and reset our design intent so we have our symmetry on. And I'm going to put this right up here on this edge. And as I rotate that to add angle, notice it angles both sides again because it's keeping the part symmetric. Finally, let's take a look at importing a part from another CAD system into Solid Edge and what we can do to manipulate it using synchronous technology. So here I have the start of a robot claw mechanism. You may have seen something similar to this, and so what I've done is I've downloaded a step file from a website like GrabCAD, and I've downloaded that, and now I'm going to import that into Solid Edge and make some adjustments to make it fit our assembly. So let me go open up the step file. It's called the flat clamp jaw, and we're going to open that into a metric part template. And so there's the imported part. It's kind of hard to see, so let's go ahead and change the color. Make it a little easier to see. We'll make it a yellow. That's a lot easier to see. And so I know that the arms, those red arms, have to fit inside of this slot. So the first thing I want to do is see what the width of this slot is, and it appears to be 14 millimeters. So let's go back over to the clamp mechanism and let's look at what the height of this, and we can do that with the inspect tool, and we'll just measure this line, which is the height of that arm. It looks to be 9.5 millimeters. And we have 14 millimeter gap, so we need to drop that down to about 10. So remember that with synchronous technology, I don't need access to the features. I can change the model directly wherever I want to. I've added this dimension, and if I click on that dimension and I start scrolling that dimension, you're going to see that it is seeing the symmetric face on the other side. It's also pulling the offset face that's down in that slot at the same time. And so I actually want to keep the width of the ears, the original width of the ears. So what I'm going to do is I'm going to add another smart dimension real quick here for that height, and what I'm going to do is lock that dimension. meaning that dimension can't change unless I actually physically edit it. So now if I pick this dimension and I start changing it, it's actually going to maintain that width and actually change the overall height. And so let's go with 10 millimeters to make sure that it fits over our 9.5 millimeter arms. The jaw that I'm going to be using is going to be picking up a fairly large box, relatively large box. So this jaw is a little bit too short, so I want it to be longer. Well, with synchronous technology, I simply select the face I want to change, click the arrow, and start to drag. Now notice that it's extending down to a sharp point, which is not what I want to do. I actually want to maintain the size of that face, so we have an option in Solid Edge to tip, meaning it's going to tip the angled face, do whatever it needs to do to maintain the size of that face that I selected as I drag that out. Let's go another 30 millimeters. Now I know what you're thinking, what about these teeth? They now need to extend down the full length of that jaw, but we don't have a pattern. This is an imported part with no features. Fortunately, with Solid Edge, we have a proprietary tool called Recognize Patterns. I simply select the face that I want it to recognize a pattern of, and it comes back and says, yes, I found a linear pattern. That's great. Now that we have a pattern feature in Solid Edge, I have something I can edit. So I can change the height. I'm going to go, or the length of the pattern. Let's go with 79. Going to add in 30 millimeters. And then I also want to change the count. Maybe I want 16 of those teeth. So we went from a part that was imported that had no intelligence based in it whatsoever to be able to change whatever we want to based on on the faces that we select. So pretty powerful. Alright, so let's go ahead and save this now. I'm just going to save with the same name as the step file was. So we'll go to the parts library. We'll go ahead and rotate the jaw into a position that's close to the orientation that we need, and we'll bring that in and place it in the assembly. To place it in the assembly, I'm going to go ahead and mate the bottom face to the bottom of the arm, and then we're going to align the end holes. And so now if I use the drag component, you can see that I can simulate that thing opening and closing. Now clearly we need a jaw on the other side, and it takes the same relationship. So we can capture those relationships using a command called capture fit, where we can save the mate and the two alignments. What that does for us then is when we go back to the library and we bring in another jaw, you can see that it automatically has the face highlighted that we want to mate, put it on the top. The first hole we want to align to this end, and then the second hole we want to align to this side. Now if I use the drag component command again, you can see I can move that side as well. Notice there's no gear relationship between the two gears. We need to add that. So before I add the gear relationship, what I'm going to do is I'm going to rotate this gear in a position where it's in a fully open position, but yet the gears appear to mesh. Now we're not actually going to make physically meshing gears. We're going to use a relationship to do that, but we want it to look good, so we're just going to get it close. That looks about right. And so let me hide this top plate. And I'm going to use the assemble command to create a gear relationship. You can see all the different types of relationships we can create. We're creating a gear relationship between this gear and this gear. And we're using those cylinders to highlight their center points, or their center lines. And you can see right now the arrows are pointing in the same direction. Gears, they have to go in opposite direction. So we're going to use the flip button to make it go in the opposite direction. We also know the ratio is 1 to 1 because it's the same number of teeth on each gear, because it's the same gear. Now that we have an actual gear relationship and we use the drag component, now you're going to see that those gears appear to mesh using that gear relationship, and both jaws will move. Now as we keep pulling them closer together, what we find is that we have interference. Obviously the gears the jaws overlap. So to fix this, what we want to do is change the length of this arm. Now just to make it a little easier to see, I'm going to change the material color on this. We're going to change that to white. Let's go with white glass on just that part, so you can see that arm that's in there. So what I want to do is change the length of the arm to move the clamp jaw further away. And I can do that by selecting the face. So right now I'm selecting parts. In synchronous technology, we can modify that part at the assembly level using the face selection. So at the assembly level, without having to go into the part, I can select the face of the part. This arc, or this radius on the outside, is concentric to the hole, so my design intent manager is going to pick that up for me automatically, and all I have to do is start to change the length of that arm by dragging it out, making it longer, and as I make it longer, it pushes those jaws further apart. It looks like about 3.9 millimeters will push those jaws far enough apart that they don't interfere with each other, but are very close. And so you can see how powerful synchronous is in the assembly level to be able to modify parts at the part level without having to jump in and out of parts. So by now I hope you've seen the power of synchronous technology and what differentiates Solid Edge from all other CAD systems that are on the market. So the other exciting thing is Solid Edge is 100% free for students and educators. So if you're going to be using Solid Edge for academic use, just follow the link below to Solid Edge to go download it, and then also there are links to self-paced learning so that you can learn Solid Edge today. With that, I hope you enjoy the rest of eFest, and we'll hope to see you next year.
It's raffle time. To win, answer the question in the chat box. ASME eFest staff will manage the chat feature and determine the winner or winners accordingly. Follow and interact with the chat to win.
Hello everyone, and welcome to the inaugural ASME eFest Digital. My name is Twish Mehta, Chair of the Global ASME eFest Steering Committee. We hope you find today's program rewarding and inspiring. Good luck to all of our competitors, and we hope to see you at a future ASME eFest.
Hello, eFesters! My name is Valentina Alayan, and I am a Strategic Project Specialist within ASME's Marketing Department. I'm really excited for all of you to be joining us here today, and I wanted you guys to make sure to stay tuned for my 2 sessions today, one of them on member benefits and the other one on programs and opportunities within ASME. But before we watch those, let's flash back to when I was a lead student organizer at eFest West at UNLV.
Hi, my name is Martin, and we're from California Polytechnic University, Pomona, and this is our 3rd year competing with our bike here called the Spirit of Kevin.
We made the bamboo slur bike, made completely out of bamboo, so we're pretty excited to be the only team here that's bamboo.
Our vehicle is named Hachiko. It's a semi-recumbent bike, mostly made out of aluminum.
We feel really, really great about the competition. We hope to, give it our best shot.
This year we had a better vehicle, a lot better than last year. It's lighter, it's stronger, and we have drivers that are more fit.
If we don't win, it's still a very valuable learning experience. Whatever we've developed thus far has been meaningful to each and every one of us. The lessons learned go beyond this competition itself, so it's a win-win situation either way.
Very complex machines in some cases very simple, some with treads, some with wheels, some with hydraulic mechanisms to lift stuff and so on. They all have the same challenge. They have to do certain things, but they're just so different in the way they've approached them.
Yeah, we started this design process about 7 months ago. We went through the engineering process of preliminary design report and critical design review. We've been up this whole week, very late, trying to get our project done.
The biggest thing that we failed at is we did not read the rules as clearly as we should have.
Going from concept to manufacturing, I believe that was the hardest part for us.
I've studied electronics, I've studied material science and 3D design, and I think this has been a really good connection with everything.
I'm only a freshman, so it's been a really good opportunity because stuff I wouldn't have been able to do until my 3rd year, getting in the workshop and everything.
I've learned so much more about robotics from building this robot than I knew 2 months ago.
eFest has been an outstanding event.
coming out here and seeing the ingenuity in their vehicles, their passion for the race, how they work hard night and day to make those vehicles run, it's outstanding. I think the opportunities here for students to interact with each other face to face is critical. Sometimes they don't get enough of that in their academic experience, the ability to work as part of a team. We really offer that extensively here at eFest through our various competitions, through our networking events, through our social events.
You know, creative work needs to be playful. It needs to be exploratory. You have to experiment.
Love meeting all the different chapters from other universities, because a lot of time in our little university, I feel like our club is just the 6 members of ASME, and I forget how much broader it is. And so it's fun to meet all these other students who are equally as interested in mechanical engineering and as dedicated.
Most of my experience has been with people in Utah, and so getting to know people in California and New Mexico and all these different places has been really cool.
Everyone put in countless hours of training and weekends and no sleeping, and I think it really paid off. I'm extremely proud of them. I can't believe how far they've come from the beginning. I don't think they can believe it.
So my best piece of advice was, remember, the person that you're competing against the most is yourself. So focus on your team and your strengths and what it is that you can do and what you have worked hard for. Just work on making sure that your team is putting their best foot forward and they have the same goal.
Hello everyone, I am Marilyn Aline Clover. I am the program coordinator at ASME's Engineering for Global Development Group and at Engineering for Change. We are really trying to educate and activate the engineering global community to solve pressing global matters such as COVID-19 and many others we are facing around the world in water, sanitation, energy, housing, etc. For eFest Digital, we offered students the option of a new additional elevator pitch challenge statement, and this is related to the current COVID-19 pandemic. So the elevator pitch of 90 seconds or less is intended to sell your ideas and skill set to potential employers, decision makers, or influencers. You only need to provide enough detail during the presentation to attract and interest your audience and compel them to meet with you again for more detailed conversation. I am happy to announce the release of the COVID-19 elevator pitch videos for all the competitors. They are located on the elevator pitch playlist.
Hello eFesters, and welcome to the ASME Student Early Career Opportunity Session. I'm really excited for all of you to be here, and I hope you guys are having a good eFest digital experience so far. The main purpose of this session is to give you guys a little bit of an overview as to what ASME does as an organization, and then really dive into some of the program areas and opportunities that we offer both to members and non-members. I know that a lot of you guys are probably student members or at least student leaders, and therefore you might not have had the chance to gain exposure to some of these areas, or you might not know how to best utilize them to enhance your ASME experience. So hopefully by the end of this session, you walk away with a little bit more knowledge as to how to do that, and then a little bit more awareness as to what ASME is as a worldwide organization. Before we begin, I wanted to give you guys a little bit more of an overview as to me. So my name is Valentina Alayan. I am a strategic project specialist within ASME's marketing team. I actually joined ASME 2 years ago as full-time staff after graduating with a degree in mechanical engineering, but I was a student member, chair, and vice chair of my student chapter, and I actually helped organize the first ever eFest West. So this event is actually really special to me, as are all eFests, because it's where I really got my first taste of the ASME experience.
Whether you're a student or an early career engineer, ASME offers a lot of different opportunities to help you advance in your career. I know that for many of you guys, your involvement with ASME began at your local student section, but internationally, ASME has a lot more program areas that you can be involved in. So let's begin with an overview of ASME. ASME was started in 1880 by a small group of leading industrialists, but since then has actually grown to be an international organization. ASME is a nonprofit, and we are actually but guided by something called our ASME mission statement. ASME's mission statement is to advance engineering for the benefit of humanity. As you guys can see there, although we are the American Society of Mechanical Engineers, we're not limiting ourselves to advancing just mechanical engineering, and we're not limiting ourselves to just America, but rather humanity as a whole. That plays into a large part of our member base, and then also the fact that engineering is so collaborative nowadays. So let's talk a little bit more about what ASME looks like as an organization. So ASME since 1880 has grown to have over 100,000 members, of which maybe 28,000 are students. So our member base is actually made up of everything from college students to early career engineers, from project managers and corporate executives to researchers and academic leaders. It's a very diverse group, and it's extremely important to note that it's representative of the engineering community in itself. Geographically, our members are diverse as well. ASME has members in 150 countries. The engineering community is extremely global, and we really wanted to make sure that we were engaging in all types of markets and research areas. ASME is very involved in technology, and so a couple of years ago, we identified a couple strategic technologies that we wanted to focus on. As you guys can see, those are advanced manufacturing, pressure technology, clean energy, bioengineering, robotics, and many of the other subgroups within those technologies. So what we wanted to do was bring together instructors, volunteers, and experts in these areas and have them advise us as to what products and programs within these technologies we should further develop or encourage in order to meet market demands. As many of you guys have probably seen, mechanical engineers are no longer doing just mechanical engineering jobs. A well-rounded education and a well-rounded background is essential for success in this current economic climate. And so we wanted to offer programs and products that fit into this changing job market. Which actually brings us to our next topic, ASME events. Annually, ASME hosts hundreds of conferences, bringing together lead researchers, industry experts, and our volunteers. The topics for our conferences range from everything from the strategic technologies I just talked about to ASME standards and codes. But how do you find out about what ASME conferences are happening, where they're happening, and what topics we're talking about? So the next thing that I'm going to show you guys in this session is a little bit about how to utilize asme.org to figure out what conferences you should be attending. So the first thing you're going to do is you're going to open asme.org. So this is what the homepage of asme.org looks like. As you guys can see, there's a lot of different information on this web page, but what we're going to focus on right now is getting you guys to the conferences and events page. So you can see that at the top of the screen, there's a variety of different topics, and up there you'll be able to click on the conferences and events component. So once you're on there and you click on that, the next thing that you're going to see looks a little bit like this. So this gives you a general overview of what is on the conferences and events page. That way you can go directly to the page you want from the home page. So the first thing that you'll see is the events calendar. That's going to show you the conferences, committee meetings, master classes, networking, public courses, and webinars. And then for many of you students, you guys are interested in our competitions. So this is actually another shortcut on how to get to the competition pages and learn a little bit more about the ASME competitions. I know for eFest, we have the IM3D, the Student Design, the Old Guard, and the Human Powered Vehicle competition. So what you're going to do as far as accessing all conferences, I always recommend going to the events calendar. So this is what the calendar of events page looks like. And there's a lot of different components on here. So what I wanted to do is I wanted to walk you guys through this a little bit. The first thing that you can do on this page is you can filter by event type. You can select and unselect different categories and view events according to the different event types. So committee meetings, conferences, master classes, etc. The second thing you can do is you can actually sort by format. So whether it's in person or online. As far as location for our in-person events, it will actually show you what countries events are happening at, and you can select what country. And then for audiences and pricing, those go into a little bit more detail as to whether you're a professional or you're a student, and then also what price range you're looking at as far as these events go. Right now, we're looking at this in terms of upcoming, but you also have the choice to sort by month. And that way, if you know that you want to attend an event in a certain month or you're only available during a certain month, you can go and view it that way as well. I usually prefer to view it in upcoming so you get all of the events at once that way. And then you can always change your view as well. So this is the list view. The calendar view looks a lot like a calendar, and you can click on that and sort your information on your calendar. So that was about how to access ASME events. As far as our conferences go, we actually from there go on and publish 30 to 35 different conference proceedings consisting of about 275,000 technical papers. So that's actually a perfect segue into our next category, which is our ASME journals and publications. For any of you guys who have published through ASME or presented a paper through ASME, you might already be familiar with this area. However, not everyone has been exposed to this, so I wanted to take a little bit of time and talk to you guys about ASME journals and publications. ASME actually conducts one of the largest technical publishing operations in the world. We offer thousands of titles, including the conference proceedings I just talked about, ASME press books, and then also professional journals. So ASME actually has 32 individual professional journals, which consist of both technical and non-technical submissions. Some of them are subject to professional peer review, others go through editorial review, but these are all great resources for you to access as both students and then also as you go on in your careers. So let's take a little bit of time to talk about how you can access these publications and then also learn more about our submissions. So when you are back on .org, right where we found the conferences and events tab earlier, there is also a publications and submissions tab. And as you guys can see, this tab offers a lot of different pages for you to access, so let's talk about them. First, we have books, so you can always find your books, your proposal guides, and your global resellers on there. As far as our ASME journals, so like I mentioned, we have our professional journals. Those are located in the journals tab, so you can find journals, information about authors, figure out which journals you'd like to subscribe to, and then also learn more about our journal program awards. Conference proceedings, so those were the conference proceedings I talked about a little bit earlier. You can find your proceedings on there and learn more about the guide to conference publications. And then we have our ASME digital collection. So the ASME digital collection was actually known previously as the ASME digital library, and it's actually the repository of current and archived literature from ASME. So in there, you guys can find our transaction journals, our conference proceedings from 2002 to present. You guys can actually find all of the ASME press books from 1993 to present. And there's a lot more reading material you guys can access on there. There's a variety of different deals that you can utilize to get some of this information, and there's a variety of different discounts for members as well. So being able to access our publications and our digital collection is a great way to stay informed about the different strategic technologies and the research that is going on around the world. But what about gaining more skills? This is where the ASME learning and development area comes into play. So when ASME brought together the volunteers, the industry experts, and the instructors to talk about the strategic technologies, we realized that there was a lot that we could do as far as offering education into a lot of these topic areas. And that's when the learning and development area of ASME really comes into play. So for any of you guys who haven't taken a course with ASME, the learning and development page is where you would first go to access it. So we're back on .org. And then you guys can see up here, there's the Learning and Development tab. When you're on here, the first thing that you can always do is you can go and find a course. We have public courses, master classes, online self-study, and then online assessment-based courses. All of these courses are different as to both how the material is presented, sometimes the format of the class. And so you can definitely explore these and figure out exactly which one fits your needs. We also have a variety of educational partners and international programs. So as you guys can see there, as ASME is an international organization, we have partnered with a lot of different groups abroad and then also within the United States to ensure that our courses are fitting the needs of our members. So this is what the homepage of the Learning and Development page looks like. Sometimes when there are announcements, this little banner will show you guys some special deals going on. Right now, because of COVID-19, we do have discounted online courses in a variety of topics. So you can go on that page, click on there, and find out more about how to get those discounts. And then we also try to feature different courses. So right here, you have instructor-led e-learning courses. We do put out our new releases on here. And then we also do have our online self-study courses, as they're very popular as well. But just like I just showed you, you can click and find courses through the top of the page as well, or you can see all courses and sort them out that way. So ASME courses actually come in a variety of price points, and we do try to offer discounts and certain benefits as well. There's member and non-member rates. But what about paying for your education at your local university? Well, that's where ASME scholarships come into play. So ASME actually offers a variety of scholarships, some of them based on academic merit, some of them based on financial need, some of them based on extracurricular participation and leadership. So the shortest way to get to the ASME scholarships page is to actually type in go.asme.org/scholarships. But I also created a little QR code to get you guys there quicker during this session. As far as our ASME scholarships go, we give out $365,000 annually. And although the application is currently closed for the 2019-2020 cycle, you guys can always make sure that you're signed up for your emails, that you've updated your communication preferences, and the application usually opens at some point in December and goes through March. So keep an eye out for your scholarships and make sure that you guys are applying to get that money that you could be eligible for. ASME scholarships are actually an ASME student member benefit. And if you guys want to learn a little bit more about ASME student member benefits, you can come back to my session from 2 to 2:15, where I'll go a little bit deeper into the ASME student member specific benefits, how to access them, and how to use them to advance both academically and in your career.
Thank you so much for attending this session, and hopefully you learned a little bit more about ASME and ASME programs. Have fun in your next session.
Hi everybody, I'm Erin Dolan again, and thanks for joining us. For those of you who are just tuning in, I'm one of the program managers for ASME's eFest portfolio. As a new member of the organization, you'll have the opportunity to align yourself with up to 5 different technical divisions. These range in subject matters from nuclear engineering to design engineering, pressure vessels and piping, or manufacturing. There are up to 30 different divisions you can choose from. Stay tuned for 2 new videos related to the ASME Power Division and the ASME Fluids Engineering Division. Thanks and have a great day.
It's all about flow. Oh yeah. I'm coming here with high Reynolds number stamina. I can beat these rap folks whose flows are laminar. I like fluid mechanics, so go ahead, call me a nerd. But my flow's got power, proportional to its velocity to the third. And I can spit rhymes so fast you can't even understand me, mate. Because at these speeds, as spit spins, it also starts to cavitate. But I can rap faster, cause I'm a doctor of flow, apart from being a master. And I can accelerate my flow to the point that you definitely know that my speech reaches supersonic speed, so here you go. These compressible flows, they ain't no joke. Because as the high pressures get higher, you should be less likely to choke. That's why I bring the turbulence to haters, like a vortex generator. So don't blame me if your game is lame, just make your Reynolds number greater. Fast cars, it's all about flow. Private jets, drones, it's all about flow. Beaches, it's all about flow. It's all about flow.
The Power Division is celebrating its 100th anniversary
and looking forward in anticipation to the next 100 years.
The Power Conference, hosted by ASME's Power Division, is a unique event that brings together a blend of attendees from industry, research, and academia to discuss current power industry issues, applications, and emerging technologies. This is a place for power professionals to network with colleagues, discuss diverse experiences, and lessons learned in generation facilities, get training and exposure to vendors and suppliers, as well as promote existing and emerging technologies.
Will you help us lead power into the future? Will you be the discoverer of new ways to generate power? Can you help harness these vast new possibilities? Come join us and power the world into the future.
Come join the next Power Conference August 2nd through 6th, 2020 in Anaheim, California. Power Division's 100th year anniversary celebration.
It's raffle time. To win, answer the question in the chat box. ASME eFest staff will manage the chat feature and determine the winner or winners accordingly. Follow and interact with the chat to win.
Hello, eFesters, and welcome to the Altair presentation of SimSolid. Altair has been a partner with ASME since the beginning of the eFest, and we're happy to be here again in the slightly modified version. My thanks and commendations go out to the eFest ASME crew for pulling together something so quickly and giving us at least something that we can enjoy this year. But as I mentioned, I want to talk about SimSolid. SimSolid is a finite element analysis tool that will result in a tremendous reduction in the amount of time it takes to do an analysis. And as you're going to see here, a massive reduction in the amount of time that it takes to set up an analysis. So what I want to do in this this first video here, and we're going to have two videos. This first video, I just want to introduce you to the idea of SimSolid. We're going to run a quick linear structural analysis, and then we're going to post-process it, take a look at the results, and that'll lead us into the second video where we're going to investigate some of the more advanced features of SimSolid. We're going to see some other cool things that SimSolid can do to make your job easier. So the first thing that I want to do is I want to bring some geometry into SimSolid, and I'm going to do that by coming up here either to my Project tab and Import from File, or I can come to this icon right here, Import from File, and this is going to allow me to bring in some geometry. And I've got a drone body file here. The modified version we'll deal with in the next video. But I'm just going to open this up, and you'll see very quickly it's going to open that geometry up. It'll give me a representation of it on the screen, and we'll rotate it in just a minute. But most importantly, or very importantly, one of the very first things that it's going to do is it's going to open up this automatic connections window here. You're going to see shortly when I start investigating this model that this model is actually about 20 to 30 different pieces put together. And what we want to make sure is that all of these pieces are connected together. And what SimSolid is going to do is it's automatically going to do that for us. It's going to look for gaps and connect them, and it's going to automatically look for penetrations and fix those as well. Now, it's not going to be able to handle very, very large gaps or very deep penetrations. You can adjust these tolerances here. But if you've got very deep penetrations or very large gaps, that's something you're definitely going to want to handle in your geometry tool. But for just standard everyday gaps or penetrations, it'll find those and adapt them. I can change my resolution to increased if I find out it's not connecting things properly. But for the most part, it's gonna to do it quite well on its own. I click OK, and you'll see over here it's going to populate all of these different connections here, and we'll get back to those in just a minute. But let's take a look at our part first. So let me rotate this around. Now, to rotate, I am holding down my left mouse button and I'm dragging it. To pan the part, I'm holding down my right mouse button and dragging that, and then zoom in and out with my scroll wheel using the pointer as a focus. But we do want to make sure that that SimSolid is as convenient and easy to use as possible, and something that Altair is kind of making standard nowadays. If you come here to Settings, and you come to mouse settings, you'll see that you can change your mouse type to match some of the more popular CAD products out there. Right now it's set for SimSolid, so 3D rotate with the left mouse button, zoom with the scroll, and 2D pan with the right. If I change that to another common one, SolidWorks, you see it's going to change it just a little bit here to adapt to SolidWorks, and then I can set that as the default if that's what I want to use. Now, I'm not a SolidWorks user. I'm just familiar with the SimSolid controls, so I'm just going to set that back and click Cancel. But that's going to allow you a better transition between your CAD product and into SimSolid. And now, as we kind of zoom around and rotate around here, we can see a little bit more of the complexity of this part. I mean, it is a relatively simple part, but it's a number of parts put together. You see that even these arms are kind of broken up into different pieces here, and we even have representations of the bolts that hold this together. And here we don't have bolts in there, but that's okay because SimSolid has gone through and made the connections for us. If I come here, open up my or expand my connections, and I click on any of these, what it's going to do is it's going to show me the two pieces that have been connected together and a representation of those connections. So I can go through, and if I want to, I can investigate to make sure that everything's properly connected together. And you see it's even done so with my little spacers and my bolts here. I'm not going to go through every one of those because I'm pretty confident that it's done a good job of that. But you can go through and investigate and make sure that all of your connections have been properly made. And if they haven't, you can just adjust those tolerances. Now, coming back up here, you'll see that I can change my units. Change them to whatever I want, inch, pounds, or millimeters, and then change the actual values within them. And then you'll see that every one of my design studies, and when we get into the more advanced features, I'm going to talk to you about the different design studies, but those are going to show up here, and all of the information for that design study is going to appear beneath it. So the very first thing I'm going to want to do is come to my assembly here, and this icon right up at the top here is my material. These parts have not come in with material. If you're using a system that assigns materials, many of those will come in. In fact, if I come here and you see, if I come to geometry import settings, it will import materials if those are included in your in whatever system you're bringing them in from. In this case, it's just a simple step file. There aren't materials. So I'm going to want to come here, click my material button, and you'll see we have a very, very extensive library of materials. And so I'm just going to come down here to my plastics, and we'll pretend that we 3D printed this thing in its entirety. So I'm just going to come to ABS plastic, and I'm going to click apply to all parts. Now you see here it also says apply to selected parts. I don't have to apply the same material to the entire model. I can select parts, so I'm going to apply to all parts and click OK, and now you'll see all parts will be indicated here as ABS plastic. But if I come to an individual part, and then I come to here, and I change that to, we'll just change it to gray cast iron, and I click apply to selected part, you'll see that that part alone now has been assigned that. So I can go through and I can do multi-selections. So I can apply materials to my parts en masse, or I can apply them individually. And that's it. The geometry is now ready to analyze. That's really all we had to do was just bring it in and allow it to do the auto connections and then assign the material. So the next thing I want to do now is tell it what type of analysis I want to run. And I'm going to do that by just coming up to here. And you'll see we have linear structural, modal, dynamic, and thermal analyses. We're going to start off just running a simple linear structure analysis. So I'm going to click that, and I'm going to say structural linear. And as soon as I do that, under my design study, it's going to add a structural analysis, where my advanced solution settings, all of that. But I'm going to leave those alone, and I'm just going to come to define my my analysis. And as soon as I'm in the structure, now the icons along here have changed for my structural analysis. These are my constraints: an immovable or encostra support, a sliding support, a hinge, or a spring support. And then down here, I move into my forces: a pressure, force or displacement, a gravity load, inertial load, remote loads, thermal load, bearing load, or a hydrostatic pressure. So let me define my my constraint first. Sorry. So I'm going to come here to my constraint, and it's an immovable constraint, and I can apply that to a face, an edge, a vertex, or a spot. So I'm just going to rotate my part over, and I'm going to apply my constraint to the bottom of these feet here. Since it's already set for face, all I have to do is click the face. It highlights that. It puts that into there, and now I'll click this. And don't worry that this is no longer highlighted. It is saved in here. The orange is just indicating the active or the last thing that I just selected. So I just go through and click each one of these four faces, and they're all in there. And now if I click OK, I will get these little icons on here. They look like little check marks or little X's, indicating that those four bottom faces are constrained. The next thing I'm going to do is I'm going to apply a force. So I'm going to come here to my force, and I'm just going to say a force or displacement. And again, I have the ability to do a face, an edge, a vertex, a spot. Now, it's not really easy to see until I switch to edge, but there is a square here, kind of representing some sort of package or something that's been attached to this, and that's going to represent the force. So we'll imagine that this thing has come down and landed pretty hard, and you know, it could be the camera, it could be the controller, whatever on this drone is going to impart a force. So I'm going to put it on that edge. I'm just going to grab that edge there, and then I just have to come down here and indicate the direction that I want that force to go. And if I need a reference, I can come here to my triad. So I'm looking for the z-axis, but I want that to go down. So I'm going to come here to my negative z, and we'll say negative 20 pounds. And click OK. It doesn't look like anything happened, but because it was negative, the arrows are going to come down from there, so you see them on the inside of the body. And that's it. It's ready to run. And as soon as I've got that set up, you see this icon now becomes active, my little run icon. And had I not been talking through the entire thing and kind of doing a little demonstration, I could have had this in and running in probably about a minute or less. And now this is where you're going to see the true power of SimSolid. I'm going to click this little button right here, this solve button. And as soon as I click it, you'll see this screaming across the bottom here. And as quick as that, it's done. The analysis is complete. It has done a full finite element analysis on here. And in fact, if I right click on this and say info, you're going to see my total runtime, 5 seconds. 5 seconds to do a full multi-part finite element analysis. Now, your results may vary. A far more complex model is, of course, going to take a bit more time, but we are talking potentially orders of magnitude difference in analysis time between this and a traditional FE product. So seconds to minutes are now seconds, minutes to hours are now minutes or seconds, and you're going to see a substantial reduction in time. But now that I've got this, all I have to do is come down here to my result plot. I'll click that. It's going to give me a list of all of the results that I have available. And we'll start off with displacement. So I'll click displacement. It's going to show me a displacement plot. I can animate this. So you're going to see it's diving down a lot there, but don't worry about that. We automatically scale up the deformation results, or not the results, but the animation. So all I have to do is come to here, change max deformation. Click that. I got a little slider here, so I can really exaggerate that. But what I'm going to do is I'm just going to click this the easiest way, and now this is showing the true deformation. You see, we still are getting some deformation in there, but now this is the true actual corresponding to these values up here, which usually is what we don't want. For a linear static part, the deformations are relatively small. So I'm just going to bring this down just so we can see the behavior of it a little bit more than the true deformation, so we can see the behavior, but not have it be so ridiculous. And close that, and we'll take a look around. And you'll see that the results are animating as well, kind of going from 0 to nothing. And I can stop the animation. I can move that to wherever I want along the shape here. Show the deformed shape, which takes it all the way to the end. Or now I can come to here, and I'll take a look at von Mises stress. So we want to see the behavior of this, and we can see we've got some stress on there. I don't offhand know what the yield strength of ABS plastic is, but we definitely have some stress going on in there. And now I can of course animate that. We can see the stress there. But what I want to do in preparation for the next video, where we're going to talk about a few of the more advanced features, is I'm going to come over here and I'm going to click this snap bookmark. What that's going to do is it's going to take a snapshot of everything that I have set up here. So my orientation, and whatever I have animated. Let me come here and we'll come to displacement, and I'll take a snapshot of that as well. So I've got my displacement and I have my my stress. And that's going to make things substantially easier and quicker for us when we start taking a look at design modifications.
Hi everybody! The SDC is one of my favorite parts of eFest. For this year's student design competition, teams were required to create a compact engineering system capable of manufacturing a tower made only of standard-sized sheets of paper. For the digital version of the SDC, teams were required to submit a 5-minute video presentation explaining their design, manufacturing, and redesign processes. I'm happy to share those videos are now available on the SDC playlist. And stay tuned, winners will be announced at the end of the day.
Hello eFesters! My name is Carlton Ramtran. I'm an engineer in ASME's Standards and Certification Department. ASME standards provide requirements and guidance to help ensure that engineers develop safe and functional products. This includes selecting materials for fabrication and construction, providing minimum design requirements, acceptance criteria, and procedures for examination and testing of equipment. Check out this video from our senior staff and volunteers that provides more information on standards and certification. I think you'll love it.
ASME is the globally recognized trusted source of consensus standards.
Standards are the backbone of the economy. They are part of our everyday life.
The beauty of ASME process is that it brings multiple viewpoints from all the industry stakeholders.
ASME's standards process does utilize worldwide volunteers and worldwide experts.
I believe ASME standards are good for business.
ASME's history is extremely rich and it's been very beneficial to society.
ASME is a leader in many areas, first and foremost known in the pressure technology area, where they got their start.
ASME wrote the first boiler code issued in 1915. There were boiler explosions occurring in schools, churches, factories.
The most important thing that ASME standards provide for our industry is safety and reliability.
ASME standard is objective, independent, and
trusted source of the standards. It is a standard used worldwide.
ASME's leadership is widely recognized. Many of the regulators around the world look to ASME first.
We've been relying on ASME standards for almost 100 years now. They're trusted. The main reason is for safety.
ASME standards are trusted because they have input from the manufacturing industry, the user industry, from engineers researching in those areas. So they become objective standards, and that is why people use them around the world.
The process is very objective and independent of any one company's personal opinion or their goals and objectives.
The beauty of the process is that it brings multiple viewpoints from all the industry stakeholders, insurance companies, government agencies, and you have to come to consensus.
We're very good at gathering all the world's experts and creating standards that are neutral.
ASME has a mechanism to recruit subject experts to join our standards committees to develop international standards.
I work in the boiler and pressure vessel area. We meet 4 times a year. Our meetings are attended by over 800 volunteers. The work continues in between meetings through electronic balloting, electronic review of proposals, openness, transparency, voluntary participation by all stakeholders. It's this openness process, the input from all the people affected by the use of the standard that makes the standard strong.
The process is truly 100% objective and independent.
ASME standards helps us negotiate arrangements globally by setting a common language that we can speak with our international suppliers.
ASME has helped keep the nuclear industry safe, the boiler and pressure vessel code. Section 3 was developed in 1963. Many of those plants that were built to the code are still in operation today and operating safely.
ASME standards give us an opportunity to make our elevators and escalators safe, reliable. New York City consists of more than 70,000 elevators, and we transport millions of people on a daily basis. The main goal of the standard is to protect the public health and welfare.
Every time you walk down a city street, you're going to see a crane. The ASME standards had a direct impact on how safely those cranes are operated. If you want to know how to perform an operation safely, the guidance document that you should use are the ASME standards.
There is no other standard out there that has that wide recognition and acceptance. You're talking over 7,000 ASME manufacturers that fabricate using the ASME code.
Standards are actually a really important aspect of medical device evaluation. When companies want to get their products to market, it's really important that we have an understanding of the safety and reliability and performance of that device. So standards play a key role in identifying what are those standard performance metrics.
As much as technology changes in the world, ASME recognizes that we have to evolve and stay current.
Standards are living documents. It changes to reflect the new technology and innovation in the industry.
Today, one of the hot topics is additive manufacturing.
On the Committee for Verification and Validation, we develop test methodologies and approaches for evaluating the accuracy and credibility of computational modeling applied to a wide range of mechanical engineering disciplines. And I think there isn't another standards group that's really tackling this issue of verification and validation. And so it's really exciting to be a part of that with ASME.
The B30 committee is in the process of introducing a new standard that covers the use of drones in inspections of cranes.
ASME is in a unique position to develop standards for new technologies that are coming on the market.
I think ASME standards have helped my company build a reputation for safety and quality and reliability.
ASME is the leader in standards development all around the world.
The ASME standards process is the best in the world.
Giving our next session, we have Dr. Jeff Hansen. Many of you guys may know him as the Emmy sensation on YouTube that helped you pass statics and dynamics. But Jeff is actually the faculty advisor for the ASME student section at Texas Tech University, and he is also the chair of the ASME Student Programming Committee. Let's take a look at what his session on his career journey is all about.
Hey gang, welcome to Virtual eFest 2020. I'm so sorry we missed you at real eFest, that we didn't actually get to go and compete, but this is the next best thing, and so I hope this is good. Maybe we'll learn something here today. If you don't know me, my name is Dr. Jeff Hansen. This is my email address, j.hansen@ttu.edu. Feel free to email me with any questions you have about what we're going to talk about today, or just drop me a line. I am a lecturer and instructor at Texas Tech University in the Department of Mechanical Engineering, and many of you know me from YouTube. I have a channel on YouTube. It's under my name, Jeff Hansen, and I teach students all around the world, statics, solids, thermodynamics, algebra. We have all kinds of lessons on YouTube, so many of you have seen me there. And you may be asking yourself, how did I get here? How do you become a university professor from the time you graduated university to doing this? Did you just go straight through or what? So I want to tell you about my journey and how I got there, and maybe how that could influence your path if this is something that you want to think about. So the name of this presentation is My Journey, so I hope you enjoy this. So you go to university to study to be an engineer. Why in the world would you do that? What motivated you to be an engineer? Was it money? I mean, come on, honestly. You probably had some high school counselor or some teacher that said, hey, you're good at math, you're good at science, you ought to be an engineer. They make a lot of money. Well, that's true. Are your parents engineers? Is your mom or dad an engineer? Is your uncle an engineer? Do you have some kind of family influence that made you want to be an engineer? Did you take some kind of placement test? I know when I was in school, they used to give you a test, and you take that and they tell you, you ought to be a fireman. But maybe you took that and it said you ought to be an engineer. So what's your motivation for doing this? It ought to be because it's something you're interested in that you love doing. Or do you like just taking things apart and seeing how they worked and problem solving? Such as the little cars you used to get when you were a kid, and you'd pull them back 6 inches and let them go, and they'd go all the way across the room. How in the world does that thing go that far on such just a little bit of, storage of energy there? I want to know what's inside of this thing. That was me. So why did I choose to become an engineer? When I originally went to university, I thought, I want to be rich. I'm going to make a lot of money. And so who makes the most money? I've got it. So doctors make a lot of money. I think that's what I'll be. So I took 1 year of pre-med. Freshman biology was all it took for me to say, I don't think so. I had a book this thick, weighed 40 pounds, and they said, hey, memorize every cell structure in the world. And I was like, I want to rebuild a small block Chevy. I don't know about cell structure, so that's out. I'm done with that. So that was not for me. So I thought back, what do I like to do? As a kid, before I got to school, what did I like to do? Well, I had toys like these, right? Anybody this is probably not my best work. Actually, my son built this. These are Legos, right? And we all had a set of Legos. Did you love building stuff? I rebuilt lawnmowers. I built go-karts. I put an engine in my dad's truck. Anything I could get my hands on to build. My grandfather had a wood shop. I was interested in tools and how to build stuff. So that's what I enjoyed doing. So that's why I picked engineering. You see some pictures on this next slide here, and it has pictures of some of the toys that I had when I was a kid. You see Legos there. You see lawnmower engines taken apart. And you see an engine coming out of the back of a 67 El Camino, greatest car ever made. And actually that was my first car, and I still have it. So since 1983, I've owned that El Camino, and it's awesome. That's why I said, I think I want to go be an engineer. So I completed an engineering degree with honors. Thank you very much. And I emailed out 400 resumes. And guess how many job offers I got? 0. So now what do? Well, I got an offer from National Institute of Occupational Safety and Health to go back to grad school. So I said, okay, if you're going to pay me, I'll go to grad school. So now I've got a master's degree. It only took me 3 semesters to get it, so that was fast. Now everyone will want to hire me, right? Well, not really everybody, but I did wind up finding a job at a local company doing military contracting. So my first job was a military hardware contract engineer. And we worked producing things like steam cleaner units for the military, for field service of heavy equipment, lubrication units, kitchen units, but mainly field service units. So if you've ever been in the military contracting business, it's kind of scary because when those contracts are up, the contract is only for a certain number of units. But once that contract is up, the job is over with. And so when we reached the end of the contract, however many units we were producing, they laid off everybody except for me and a shop manager. And it was my job to get the next contract in order, and then they would go back and hire everybody else. I was getting paychecks and they were saying, hey, don't cash that till next week. Hold that money until we get, we were in a bad situation. And I thought, this is not the place for me to be, okay? So I tried to get out of the contracting business as quick as possible. You can see here on the next slide a couple of pictures of some of the units that we built. On the left would be a steam clean unit, and on the right there is a picture of one of the lubrication units, the trailer mounted lube units. So I found a new job as a manufacturing engineer at an injection molding plant, okay? And it was here in Lubbock, Texas, where Texas Tech is located. It had a better pay structure. I didn't have to wait to go to the bank to cash my checks. They were ready to go when I got them. Of course, the first paycheck I got, all the guys in the office came and wrote on my paycheck, do not cash until next Tuesday. Very funny. Okay, gave me a heart attack. I thought, what if I got myself into again? When I started that job, there were 400 employees at that company. Every molding machine, when it would make parts, somebody would slide the door open, take the part out, slide the door closed, it would make another part. Our job was to go in and automate that and put robots on every machine with end-of-arm tooling to do any secondary operations to get the part out of there, to have consistent cycle times. And we took that plant from 400 people to 125 people doing the exact same amount of work. So I was on a 4-man automation group that went and automated that plant and took that labor complement from 400 down to 125. So we made parts, as you can see here on the screen, for the consumer industry, things that you can buy at Walmart and Target, for the Christmas, mainly for Christmas, which was tree stands and suction cups, shingle tabs. Matter of fact, the shingle tab was invented in Lubbock, Texas, and we produced parts for the inventor. They started at our company, and I was the plant manager of that plant. We also made automotive parts. We're probably best known for making bearing components. And then we also made parts for the telecommunications industry. So here's some examples of some of the interesting parts we made. Here's a couple of bearings. These are tiny. Okay, these are bearings for TRW. These actually are bearings in your seat belts on your car. And so, and then these are some small little retainers. These are actually go in the U-joint of your car, little pieces here. And then we made fun parts like this. This was a pig out pumpkin. This is a blow molded pumpkin with poppets on it. And as your candy bucket got full, you could pull him and expand your candy bucket. But we made all kinds of holiday parts in my factory. So after 8 years, I had worked my way up to plant manager. I had 82 people working under me, and I thought everything is going great, right? And the boss calls me in one day. He says, hey, we got to have a talk right quick. And I said, okay, what you got? You're laid off. I said, what? Why would you, what's going on? Well, we've decided that engineers make too much money. We had reduced the labor from 400 employees down to 125. And they said, you know what? The plant's running great right now. Our margins are as good as they've ever been. And so we think that we don't need engineers as on staff anymore. And so they laid all the engineers off, and they just handled everything that we had built with a maintenance crew. And so there I was out of a job in one day. And I thought, this is the worst thing that could ever happen. How am I supposed to support my family? I had a 1-year-old baby, and my wife, and how am I supposed to support my family when I don't have a job? This is the worst thing ever. So I was unemployed again. So one day while we were going back home for Christmas break, I told my wife, we were driving home, I said, you know what, I think I want to get a PhD. And she said, why in the world would you want to do that? And I said, I don't know. I'm tired of getting mail that says Dr. Miss Hansen and Jeff Hansen. And so I want a title too. I don't even know why, but the company would pay for half of it. So I'd been working at the molding company, and they had paid for half my tuition the whole time I was doing that. So I was pretty well along into a PhD program when I got laid off, which is really another word for getting fired. So I really believe this was a blessing in disguise. At the time, I thought it was the worst thing ever, but it turned out to be the best thing that ever happened to me at that time. Now I have more time to pay attention to my school, pay attention to my family, and I need to find a new job. So it turns out it wasn't that bad. The next day, I got asked to join the family business and went into work for my wife's dad, which gave me tremendous flexibility to do whatever I needed to do for school, and gave me pay right away the next day. So I never skipped a beat. I didn't think about that industry, but there I was as a sales engineer. So I have a question for you. Do you believe things happen for a reason? I do. Let me tell you this. So working at my new job, I have to do a job for a local community college. It's called South Plains Community College. And I'm putting in some pallet rack and things in their diesel tech center. And the dean of the College of Engineering happens to be over there, and we get to talking. And he says, oh, you're working on a PhD. And I said, yeah. And he said, so you must already have a master's degree. And I said, well, certainly I do. And he said, well, then you could teach for us. And I was like, okay, yeah, right. I had never, ever considered being a teacher, ever. And he said, well, I'll call you sometime. I'll get you a class. He said, could you teach engineering graphics? And I said, yeah, I use AutoCAD all the time at work. And so I don't know why I couldn't teach that. I'll give it a try. Yeah, but whatever. So that was the end of the conversation. I didn't think I'd ever hear from that guy again. Well, a year later, the guy calls me and says, hey, I got a class for you, a night class out at one of our branch campuses, and we want you to teach engineering graphics. And I was like, okay. And so there I was. Suddenly, there I was teaching engineering graphics. Yeah, that says 2007. That's about the last year that I taught that. This was my last textbook, actually. I was so nervous, y'all. Here I was teaching a class. I've never taught a class before. Why would anybody want to listen to me? I don't know what I'm doing. But it didn't take me long to figure out that I knew more than those students did. And then it didn't become so nervous. And they really caught on to what I was saying, and they really liked me as a teacher. And that made the whole thing so much easier to do. And so I loved it more than anything else. And so there I was. I think this is a new career path that I want to pursue. So in the fall of 2007, bam, PhD, baby. Got her finished. And before I left the university, the industrial engineering department offered me a job teaching a class. So I had my regular job. I had another job really selling eBay parts. And now I had another job teaching class. So I was very excited to be teaching class at Texas Tech University. That's a Division I school. That's a big deal. This isn't community college stuff. This is the big leagues. So the day before the semester started, I was just cruising through the building, getting my class assignments, whatnot. And I went by the mechanical engineering department and I said, hey, let me give you a resume. And so I dropped off my resume to a guy in the ME department and I went back over to my office. But by the time I got to my office, he had called me up on my iPhone 10. No, not my iPhone 10, my iPhone 1. Look at that. That's an iPhone 1. It's tiny. Here's the 10. It still powers up though. And they said, hey, we got a position open. We had somebody coming from another country. They couldn't work their visas out. And we need somebody that can teach senior design in mechanical engineering and statics starting tomorrow. Can you do it? Now, this is an important lesson for you guys right here because I said, heck yeah, I can do it. I hadn't had statics since 1988. But I found one of the other guys that was teaching my classes on Tuesday, Thursday. Another guy was teaching on Monday, Wednesday, Friday. So I'd sit in his class and then teach my class the next day. So the first time I was always one day ahead of the students. But I learned it, I went through it, the students loved it, and the rest is history. Would I be doing this job if I hadn't been able to find a job when I got my undergraduate degree? The answer is no. The job economy at that time was really bad. And if I would have found a job, I would have gone to work. I promise you that. Because there was zero on my radar about being a professor at university. It was not even on there. I don't know that I'm smart enough to do that. So the whole point of this conversation is, how do you find your dream job? The first thing you have to do is you have to be intentional about that. You have to sit down and ask yourself, what is it that I like to do? Is it robotics? Is it airplanes? Is it cars? Is it the medical industry? Is it whatever it is? Go pursue that field, because what you want to do is, with whatever you do, be happy with what you're doing. The first job I took was just the only job I could find. It wasn't what I had planned out. But times are different now. There's job fairs, there's the internet. We didn't have the internet then. Well, we did, but not that you could access. And so things are different now. And if you are intentional about thinking about what it is you want to do, you'll be better off choosing your career path, because life is short. You don't want to go to a job every day that you hate doing. You've got to go do something where you can make a difference in the world. We're only here for a certain number of days. So what are you going to do to make a difference while you were here for other people? Remember to put yourself in a position for future success. And I'm going to show you a few things that are going to help you do that. Number one, whatever you do, I don't care what it is, do the best job that you can possibly do at that job. Every year as a professor, I get feedback from the students. There's a lot of positive, but there's some negatives. And I look at those and I say, how can I do this job better? Once you quit caring, you stop doing that, it's just downhill from there. So I still feel like I learn something new every single year that I teach class. Even though I teach the same class over and over and over, it gets better and better and better every time I do it. If your company asks you to stay late, then you stay late. You always volunteer for overtime. If there's a project that has to get out the door, you stay late and do it. Don't think that you're going to be there from 8 to 5 every day. Those people are the ones that will never advance. You're going to be in a closet somewhere designing gears for the rest of your life. You're never going to advance up the ladder through management, because once they ask you to do something and you say, no, I don't think so, then they don't ask you again. You're out. But if you're the guy that's always there, that's dependable, we can ask him for anything. He does whatever we need. Let's get him on this project. Let's get him. And I can't tell you how many people in the industry that I've talked to that said, CEOs of companies have said, I'm the CEO because I said, yeah, I'll go do that job when no one else wanted to do it. So volunteer for those jobs when they ask you to do it. Don't say no. Be sure that you're the first one there every day, and be sure you're the last one to leave. Show up early, leave late. If you're there from 8 to 5, it tells them exactly how much you care about what's going on. And you won't have to do that for your whole career, but when you're young and able to, that's what's going to help you advance up the ladder and get you into a position where you don't have to do that every day. But when you first get out of school, you got to be killing it every single day. Finally, you may not think it's important now, but keep working on your education. Throughout your career, keep pursuing an education. Because when I got a master's degree, I did not want to get a master's degree. And if they said, what would you do with that? I don't have any idea what you do with a master's degree. And then I wanted to get a PhD. What do you need that for? I don't know, just so I can have it. I don't know, the company's paying for it. I'm just getting it for just because. But that opened up a door for me that I didn't even know existed. And so you don't necessarily know what your whole plan is. You know, wish we had life mapped out, but we just don't know what's coming down the road. But you want to be putting yourself in a position where you're set up to take advantage of that opportunity when it does come knocking. Finally, let's talk about networking. And I know you've seen a lot about networking, but develop good networks, because you never know when you're going to need a job or when you're going to need something, and you're going to know who has that and who can help you out. When you're at events, get people's business cards. And then know something about them. Learn their name. Learn something about what they do, where they're from. Something personal about them. And then later on, a couple days later, send a follow-up email saying, man, it sure was good to see you at that event. And I really learned a lot from you, and I look forward to seeing you again. That little connection is important because, again, you never know when you're going to have to call on one of those networking connections down the road. So I hope this has been helpful. I hope it's been interesting to see exactly how you get from here to there, at least my journey. Your journey is certainly going to be different. And I hope that yours is great. I hope yours is better than mine. Mine's pretty good. I love going to work every day because I love seeing you students every day. I can't believe they pay you to go do this. That's what I want you to find as a job where when you show up, you can't believe they pay you to come do this. It's fun. Because when I show up to work, it's 5 o'clock before I can say, don't do it. The day goes so fast when you're enjoying what you're doing. When you don't enjoy it, you're like watching the clock. Is it time to go home? Is it time to go home? The life's too short for that. You don't need that. So again, if y'all have any questions or you want to reach out to me, feel free to hit me up on the email there. Follow me on YouTube, on Instagram, and I look forward to seeing y'all down the road somewhere. Thanks.
It's raffle time. To win, answer the question in the chat box. ASME eFest staff will manage the chat feature and determine the winner or winners accordingly. Follow and interact with the chat to win.
Hello, everyone. I'm Sidayan Duvanin. I'm a coordinator for the student and professional sections with ASME's member development and engagement sector. If you have any questions about your section, log on to asme.org, click on the section and divisions link, then select Learn how to get involved. At the bottom of the page, you'll be able to connect with your region coordinator. I'm happy to announce the launch of the oral competition videos sponsored by ASME's Old Guard Committee. The videos are posted on the oral playlist and the winners will be announced here at the end of the day.
Hello, everyone, and welcome to ASME's first digital eFest, and thank you for joining us through these trying and difficult times for all of us. I could not figure out how to do a fancy virtual background, so I hope you like this decor instead. Nonetheless, my name is Aaron Weinerman. I'm ASME's Manager of Global Public Affairs based in our Washington, D.C. office. I'm not an engineer. I've learned through osmosis everything from your experience and expertise, so thanks for that. Since this is very much a global event, I want to quickly highlight some of the activities of our Global Public Affairs team. We oversee ASME's public policy and advocacy efforts with governments around the world. This furthers ASME's longstanding status as a neutral convener and trusted source. We've been around since 1880, so that does help. Global Public Affairs also coordinates ASME's international relations efforts, including our China and India operations, where we have offices in Beijing and New Delhi. From a holistic perspective, our work supports all of ASME's global priorities, including programming such as this amazing eFest and EFX platform, online learning, industry outreach, and standards and certification, just to name a few. So I just want to quickly say hello. Please enjoy your virtual experience, and you'll be hearing a little bit more from me. So have fun. Talk to you later.
Hey there. I hope you all are doing well and taking good care of yourselves. This is Dhaval Trivedi, a Gujarat, India-based entrepreneur and founder of Pragrathan Rejuvenating Nature, which is a startup dedicated to healthcare and medical devices research. I had started my journey by designing knee replacement implants, that is the system for treatment of knee joint related traumas. That system is a proprietary technology now. And on that point onwards, I was fortunate enough to work on some systems such as hip replacement system implants, that is the system for treating hip joint related traumas, and some spine related products such as pedicle screws and surgery guides and tools for scoliosis and kyphosis surgeries. In this time of global pandemic, my startup is stepping up as one of the source of providing 3D printed products such as expiratory valve, which are typically used for breathing circuits on the ventilated patients, and one more design called as the suction toothbrush, which is a design that is based on suction principle and used for oral hygiene and cleanliness of the patient. Because we believe that along with the mainstream medication, the oral hygiene is equally necessary. We have kept this design as open source so that it can be used at any part of the world and the design can reach to its desired destination. Along with, the startup is working on one more possible device for the hyperbaric oxygen treatment. This treatment is used for immunity boost up in the patients.
We are the engineer. We are the future of engineering. In an ever-changing global development landscape, the paradigm is shifting, and we are leading the way.
We are empathetic and collaborative. We are accountable global citizens.
We are mobilizing a community. Our community will drive the change.
Information is power, and we are here to empower. People first, technology follows.
Breaking barriers between vocations, neighborhoods, and nations.
Provoking new ways of thinking, new ways of doing, new ways of being.
Striving for clean water, enough food, engaged minds, light.
We can't solve global poverty on our own. Nobody can. But we want to build something better, something sustainable, something with purpose. We will be rigorous and excellent in all we do. We must. People are too important. The stakes are too high. We are engineering for change. Join us. By engineers, for everyone.
In 2015, the United Nations created 17 Sustainable Development Goals. These are audacious goals for improving the way we live on this planet. Everything from improving education to ending inequality and surely eliminating poverty. Siemens actually is engaged in supporting all 17 of the SDGs, as they're called. But we realized that the United Nations really needs business to engage in a new and different way. And we identified a real opportunity with engineering for change. It's called Innovate for Impact. Here we'll be bringing our Siemens software tools to the table. It's what NASA used to test and design a rover in a virtual environment that could survive the make or break 7 minutes of terror to get to Mars. It's what one tech company used to design autonomous drones to deliver essential medicines to remote areas of Rwanda. It's what recently enabled an ambitious teenager to design a new prosthesis for a veteran in her community. And what we'll do now is focus on 2 key sustainable development goals: zero hunger and clean water. What if we had the ability to create preservation off-grid, techniques that would help that food that's actually harvested make it to the hungry people who need it? 97% of the Earth's water is salty. What if we could identify desalination techniques that would make it possible to convert that water and put it to good use? So I'll ask you to join us. Make use of the Siemens tools. Come help us innovate for impact.
Hi, I'm Brandon, current student and volunteer with ASME Student Leader Training. You've already heard from Nicole and Maya on how to create a powerful self-brand. In just a few moments, you're going to hear from another 2 of my good friends and colleagues focusing on something we can all use help with right now: adapting to change. COVID has affected us all in ways we couldn't have possibly imagined. So in this next session, Omar and Bilal are going to share some powerful insights and tools that can help us to be better at answering this challenge.
Hello everyone, my name is Omar Kher. I'm part of the ASME Student Leadership Training Committee, and I'm here to give you a few tips today on how to adapt to life's changing variables. Everything in our world keeps constantly changing and evolving. The technology, the economy, the science. There's always something new that overwrites the older technology or the older habit. The pace of change is actually not slowing down, and it's something that people and businesses need to learn how to adapt to. Otherwise, they will fall behind and fail to compete in today's world. In fact, 80% of the jobs and the skills that would be needed in 2025 do not exist today. How can some people just adapt while some others struggle? We're losing the ability to adapt proactively because we're not taking the time and attention to prepare ourselves. We're constantly jumping from change to another without strategizing about what's next. Many researchers argue that dealing with anxiety and health issues are considered to be the next epidemics, meaning that we are not being able to cope well with all those daily disruptions. The coping mechanisms we had in the past don't necessarily work for the future. I'm just going to give you today 3 key themes that would help you better adapt to life's changing variables, whether at work, ASME volunteering, or even your personal lives. Those key themes are resilience, purpose, and the curiosity to learn. Developing your capabilities in these areas would help you become a lot more adaptable. And now it's time to warm up. Since a lot of you guys are working out from home now, let's consider adapting to change as another home workout. With each of these 3 key elements I'm going to be talking to you about, let's consider them as a move that you have to do to make your adaptability muscle stronger and stronger every time. Let's start with purpose. Winston Churchill once said that you will never reach your destination if you stop and throw stones at every dog that barks. Meaning that if you don't stay focused on your goals, you will never get to where you want to be. Those with a strong purpose would not let a storm get them derailed from where they want to be in life. So focus on finding something you're really passionate about so that you have the drive to keep going no matter what. This does not just apply to your career, it also applies to your volunteer roles within ASME. Choose the role and the volunteer position that interests you the most and gives you a purpose. If you're passionate about teaching leadership, join the SLTC. If you're interested in competitions, you can either participate in one or help organize one. So next, in our home workout for today, you have to do some push-ups, which are basically just like resilience. Each time you go down, you have to push yourself back up. Resilience is about overcoming barriers and setbacks and learning from them, which helps you become more adaptable. It's about not giving up when bouncing back after every hit you get from life. So which setbacks have you experienced that kept you off track and had you settle to be someone you don't want to be? Did you just give up after getting that job rejection, or did you try harder to find the next opportunity? So now it's time to do some push-ups. Let's do some push-ups, guys. So my last muscle fact, and of course adaptability tip of the day, is that you need to keep finding new and better workouts so that your muscles can actually grow. With adaptability, it's exactly the same. You need to always be curious about learning new stuff and be passionate about embracing the change that will happen in the future. To keep questioning everything surrounding you and finding new approaches for the same problem we're stuck at. So now that I'm done with the muscle tips that I gave you, it's time that Omar in his suit to be back and conclude this presentation for you. Overall, these are all non-genetic characteristics that can be developed and seasoned over time. You can learn to be adaptable. Humans, physically, biologically, and mentally speaking, are meant to adapt over time. The brain is usually resilient to change. It prefers to take the same usual route and think the same way. Unless we are aware of this and have a commitment to change, we cannot make a commitment to change. We all have the capacity to learn how to adapt, we just have to start somewhere. With all the current changes happening in our world, COVID-19 is just a small example on how life could be severely disrupted. We should stay focused on our goals and overcome the failures and find new ways of getting where we want to be. It takes scientifically 66 days to form a new habit. Take a few minutes now to think about what your priorities should be at the moment and try to figure out what your next habit will be in 66 days from now. I'll leave the floor now to my friend and colleague Bilal Wasim, who will be expanding a bit more on the topic and hopefully be giving you a few extra tips.
Thank you, Omar, for that information. Hi everyone, my name is Bilal Wasim and I'll be hosting the rest of this session now. I'm just going to talk to you guys a little bit more about what Omar said, and I'm going to kind of give practical examples on how to apply this information to running or helping your student sections. So first I'm going to tell you guys a little bit about my own background and how my involvement in ASME changed throughout the years and how I adapted to that. I'm sure a lot of you guys will relate to some of the things that I talk about. Next, I'm going to talk about how important it is to be being able to change as a student leader or in any kind of involvement in a professional or student organization. And then last but not least, why this topic was so relevant to pick was how do we apply these changes in a situation like this, like an ongoing pandemic and quarantine? Obviously, everything is shifting to online now, so we're going to kind of go over how an organization can be prepared for that. So as far as my background goes, I started out very kind of uninvolved member of ASME. I signed up for it at the start of my college career and I kind of just forgot about it for the first year or so. I maybe went to one event, maybe two events, but I never went to the meetings and I didn't have involvement beyond that. But as I went on throughout college, I started taking more of an interest. I started going to the meetings and I started working on projects. Eventually I elected as the vice president of my section and I started becoming way more involved. I started going to events, I started leading events, I started going to conferences. Upon graduation, I pursued this role in the SLTC team, and that came with it a whole host of new changes. I was now not involved through my school anymore. I was actually volunteering, and with that, I had to kind of change my approach on how I was participating in ASME. One of the things I want to talk to you guys about is that the nature of student organizations is that they're always in a constant state of change. Now, that could be due to the members or the leaders, but basically with every change, there's going to be a different style of student section. It's just going to be largely dependent on who's running it and who's involved. So one of the most important things is that the executive board could have different ideas from the last executive board that will obviously have like a very clear, direct change in what the goals for the section are. And second of all, the student members themselves might have different interests than in the past. So it's important to listen to input from your members because you don't want to pursue something that nobody wants to be a part of. Now, it's important to keep a cohesive goal and message and like some core principles that show that you are part of ASME, that you are running ASME. But it's important to also go with the flow sometimes and listen to what your student members are saying. So for example, with me, with my section, there was a very popular project that people did was Power Wheels racing, which is the little kids Power Wheels cars. Basically, you just modify them to go 25-30 miles per hour and race them. So that was very popular for a while, but then like interest waned for a few years. So instead of trying to push that where nobody wanted it, they kind of shelved that idea and focused on other things such as like a dynamic statue or other events. So later on, when people started wanting the Power Racing series back, then they brought it back, and it was way more successful than it would have been if we had just tried to push it while nobody was like buying it. Now, most importantly, I want to talk to you about our current situation and how you can stay involved from home and deal with the changes that come with an ongoing quarantine. Often, physically attending events is one of the coolest things about being in an organization. You get to be involved in projects, you get to work on things with other people. It's overall very helpful for your professional development. And I know with an ongoing quarantine, it's easy to lose interest, but the most important thing is to stay involved through the internet. Basically, you've seen the memes, everybody's using Zoom nowadays for classes. It's also a very good tool to use for your student sections. If you're not already using Zoom or some kind of video conferencing app for your meetings, I highly recommend trying it out, kind of gauging how your student sections are interested in it. Other things is you can still work on projects that don't require you to be physically there. So design work, anything that requires coding, you can still share stuff like that back and forth. Maybe you can think of new projects to do that have like a significant part of it that can be done online or from home. Probably the most important thing you can have in your organization to make it adaptable to this kind of change is structure. So if everyone has a clear-cut goal that they're responsible for, they can easily know what to do, whether they go to meetings or not, whether they are physically present in the room with you or not. So besides this, you should try to have a consistent meeting schedule. If people know when they need to meet up or check in for progress, they have some kind of time frame involved. Now with quarantine and everybody's kind of stuck at home, it's easy to kind of lose track of time and all the days kind of blend together, but it's important to have that kind of frame, that kind of time frame, that kind of consistent meeting schedule to keep yourself on track. So there you have it. Those are some of the ways you can adapt to change as a student leader or in any form in a student organization. Thanks for listening to our presentation, and have a good night.
Hi eFest! My name is Grace Bolin, and I'm a staff engineer in ASME's Conformity Assessment Department. What is ASME Conformity Assessment? Well, it's the recognition of a company or an individual's capability to fulfill the requirements of an ASME standard in order to advance public safety and facilitate international commerce. Stay tuned for a video from some of our senior volunteers and staff on ASME Conformity Assessment.
Why demand a mark? The ASME mark indicates compliance, confidence, and reliability.
For over 100 years, ASME has been recognized as the global leader in safety and quality.
Anybody can self-declare, but unless it's stamped, unless you have the ASME mark, it's really not an ASME component.
The consequences of purchasing unstamped products could lead to equipment failures. The ASME mark is a statement of confidence that all code requirements have been met in the construction or fabrication of that part or piece of equipment. Otherwise, you're going to potentially introduce risk.
When you have a pressure vessel item that has a stamp on it, I can know the genesis of that entire vessel. If I get a vessel that has no stamp on it, I have no idea how that vessel was manufactured.
You are unknowingly accepting all of the risk that comes with that product that isn't stamped.
But when you're buying an ASME stamped product, In the long run, it becomes more efficient when you don't have the certification mark on it. It almost becomes a guessing game on how long the vessel will last, when your inspection will have to be increased, or the amount of repairs you end up doing on the vessel.
Demand the mark because it lowers the probability of introducing risk to your project.
The ASME name in general is recognized worldwide. So I believe it gives you the company a competitive edge.
Demand the mark because it's confidence in the quality of the equipment that you're purchasing. When you're buying an ASME stamped product, you know exactly what you're getting. All parts and products within the supply chain need to have the ASME mark.
Why demand a mark? For a purchaser, it's that confidence and trust in the safety and quality of the pressure retaining item that they're purchasing.
There is only one ASME. The mark is globally recognized by regulators worldwide.
Companies all around the world should demand the mark.
Hi everybody, I'm Brandy Smith, ASME Senior Program Manager, and I'm really excited that you're here with us for our first ever eFest Digital. We're so excited that you're here and taking some time out of your day to be with us. I'd like to remind everybody to please make sure that you complete an online survey that you'll be receiving via email after the event. And now I'd like to introduce a video from the ASME Petroleum Division Collegiate Council. The following video was created to introduce and promote the ASME Petroleum Division Collegiate Council. It talks about an example of one of the many initiatives that ASME develops and organizes for college students and early career engineers like you. An opportunity for any one of you that may be interested in a career in the petroleum industry, and an example of one of the many ways you can give back to an industry and organization that will be supporting you in your professional life. If you're interested in the council or want to learn more about it, check out the website mentioned at the end of the video.
The ASME Collegiate Council is an opportunity to meet industry experts and mentors, hear presentations from professionals of all ages, while working with a team of students located all over the country.
Students that have participated on the Collegiate Council have secured jobs with Baker Hughes, with Shell, with Chevron.
It actually costs nothing for students. All you have to do is go online, apply, and if you get accepted into the council, they pay for everything. There is nothing you have to worry about.
Honestly, I don't see why you wouldn't apply.
If the ASME Collegiate Council sounds interesting to you, you need to be aware of what you're committing to. 2 all expense-paid trips, presentations by industry leaders and potential mentors, tours of industry-leading facilities and examples of what you may one day do for a living, and delivering a group project planned and agreed to by the students that benefits both ASME and the Collegiate Council. For more information, visit the ASME Collegiate Council website.
Hey everyone, my name is Sarosh Shahid. I'm the Director of Student and Early Career Development here at ASME. I just wanted to take a moment and say thank you from everyone here at ASME for joining us for this very first Digital eFest. We hope everyone is staying healthy and happy and safe. And I just wanted to wish good luck to everyone who is competing today. Please continue to stay connected with us, and we hope you enjoy the rest of this broadcast. Thank you.
it's me, Erin, again.
And it's me, Brandy, again.
Have you ever thought about hosting an eFest or an EFX on your campus? If yes,
we'd love to hear from you.
Send us an email at efest.asme.org or
check out our website at efests.asme.org.
Thank you.
Okay.
Thanks for tuning in and attending ASME's eFest Digital. Remember to click subscribe and that notification button. This way you'll be notified as we post new videos throughout the event. I'm Liam J. Holland, the Multimedia Manager at ASME, and I oversee the video production that we do. If you look around, you can actually find some of my work on this YouTube channel, as we've shot a variety of content at prior eFests, including the Human Powered Vehicle Challenge, Robot Football, and there's a behind the scenes series. It gives a small insight into what it takes to put on an eFest, and we shot that one in Rio de Janeiro. You may or may not know that we also have some other YouTube channels where you can find more mechanical engineering videos. Mechanical Engineering Magazine, this channel has a lot of content focused on the latest news and developments in the field. I especially recommend checking out the latest special report on 4D printing. We made that one entirely during the lockdown, and if you're into 3D printing, then I think you'll find that one interesting. There's also the Future ME channel, which has got a lot of useful information as you start out your career in mechanical engineering. And there's the ASME membership channel. And of course, there's the official American Society of Mechanical Engineers channel, where you can find content that spans all areas of ASME. I highly recommend subscribing to each of these channels so that you can stay up to date on all the latest developments. I hope you're enjoying our first ever eFest Digital. And remember,
party like an engineer.
Hi again, everyone. John Falcione one more time, here still enjoying eFest. I hope that you guys are as well, from wherever you are around the world. So one of the things that I enjoy the most about eFest when we do a live event, an on-site event, is that I get to jump on stage and ask you some questions about our keynote or trivia questions. And those of you who answer correctly get a cap, a Mechanical Engineering Magazine cap. So this year, I wanted to make sure to give you the same opportunity to get one of these beauties. So, for the first 25 of you, that's the first 25 of you who send me an email to my work email, which is falcionej@asme.org, send me your address, and also a nice little note would be nice. I'll send you one of these. So again, it's my last name, Falcione, spelled F as in Frank, ALCIONIJ. My first initial at asme.org. I'll send you one of these. See you soon. Talk to you later.
Hello again, eFesters! It's me, Carlton. In February, I had the privilege of participating in eFest Asia Pacific, which was held in India. In addition to offering a session on standards and certification, I had the opportunity to volunteer with the IM3D competition. With this experience, I was able to witness the love and passion you all share for additive manufacturing. So with that, I'm happy to announce the release of the IM3D videos from all the competitors. These videos are located in the IM3D playlist. Winners will be announced at the end of the day, so stay tuned.
Hi everyone, I'm Rochelle Chaplin and I'm Manager of Client and Media Services here at ASME. I've been involved with eFest for the past few years, and in particular, I'm lucky to be able to work side by side with our corporate sponsors who have provided us with some great content that we're happy to share with you today. Please make sure to check out the sponsor playlist to access that info. Hope you enjoy the event.
Well, hello eFest, and welcome back. Happy you stopped by for part 2 here. So we're going to continue taking a look at SimSolid, and we're going to look at a few more of the advanced features. We're going to start right off with working on a modal analysis. So again, if you remember, these are where we add our our different types of analyses, and we've got our structural linear, and if I come to the one next to it, we've got our modal analysis. Here I need to tell it how many modes that I want to find, and I just click OK, and that's pretty much it. So I just come here, I click Solve, and again, as quick as that, we can take a look here, Info. This one took another whopping 3 seconds, and now I can look at the results here. So displacement magnitude, and we can see the different frequencies. Now this has, looks like the first 4 or the first 6 frequencies are rigid body modes, not uncommon, or not uncommon. It's, since this was not a constrained modal analysis, it was a free modal analysis. That's the standard results. But the rest of these are the regular frequencies, and so I can view the mode shapes, the way that it's going to vibrate, and the frequencies as well. So I can come through here and see these, and these are pretty much kind of the expected frequencies. And you'll see with the rigid body modes, we actually get rigid body motion. It rotates and translates around the different, the 3 different axes. Okay, so that's modal analysis, something very important to make sure that our part doesn't vibrate at a frequency we don't want it to vibrate at. And then, of course, we can come here and look at the energy density as well and see that. Okay, so let me get out of the post-processing here. Now, there are many other ways of types of analyses that we can run: structural, nonlinear. We can do transient, frequency response, random response, thermal. I don't want the thermal in there. Let me delete that. So there are many other types of analyses. What I want to, in the time that we have here, what I want to show you is another important aspect of SimSolid, and that's analyzing design changes or analyzing different versions of our model. So if I come here to Project and Import from File, and let me come in here, and I've got another one here, Drone Body Modified. I'm going to import that in here, and it will go through the same gap analysis and penetration analysis. So I'll click OK. But the really cool thing about SimSolid in this case is it has recognized that this part is essentially the same thing as the other part. In fact, what I've done here is I've just tried to go with a thinner arm. If we come and take a look at the other one, see how the arms are much thicker. So it's recognizing it's just a different design modification from the original part. So it actually rebuilt everything that it had in there before. So I have my my constraints down here on the bottom, my forces. It redid the modal analysis. The only thing that it didn't do is if you look here, the arms, the things that I changed, it didn't create a material specification for them. So really all I have to do is I could come to them individually and assign it. But again, since this part has the same material all over it, I'll just come back up here to my materials. Plastics, we'll grab that ABS plastic, apply to all parts, and now all of the parts have there. So you just have to be aware that anything that is changed from the original model, you'll have to go through and reassign a material to. But besides that, everything is all set and ready to go. And in fact, I can just come here to my structural, click play, or click run, and now my results are all done. And what I can actually do is come to my bookmarks. So if I come to my bookmark here, it's going to show me the von Mises stress for my original part. Well, if I come down here and just click on result for my other part, now it's a direct comparison between the two. It will take the information from the bookmark and it will perform that or provide those results in the exact way that it did on the original part. And so I can just go from original to the new design. And then my bookmark 2, which is my displacement, so we can see with my original design what I get here, about 0.2 inches, and not unexpectedly, substantially more, so 1.7, oh, sorry, not inches, millimeters of displacement, which is not surprising because I didn't thin things out. So it's very easy to come here and create new design studies. In fact, I can right-click on this, click copy. I've now got this copied again, and I could do something like come here to my assembly, or even just come here on the screen and control click these, and maybe I want to find out what happens if I make these instead of out of ABS plastic, if I make those out of aluminum 7075 T6. And apply. Now I'm not going to do apply to all parts, I'm going to do apply to selected parts. Click OK. Everything is still set up again, so I just come back to my structural one, click run again, and again, in a matter of seconds, I've got my result. I can come here to my result, and I click my bookmark, and now I can see that I've substantially, oops, I'm sorry, I have to come here, and, oh, I copy, I'm sorry, I copied, I meant to copy it off of my design study too, but I copied it off of the one. I had intended to do it with thinner arms, but you can see, in fact, what the heck? It's quick enough to do that, so I'll come to Design Study 2, right-click, copy that, and now I'm down to 4. Come here to my arms again, and, oops, I have to be up here in assembly, or I don't have access to the material, and so we'll just grab these 4 arms again, come here, select aluminum 7075, apply to selected parts, OK, and now come to my structural and run this one. That's, again, the great thing about SimSolid, with the fact that it runs so quickly. So I made a mistake. I copied the wrong one, but now I've copied the right one, and it has set me back, what, a whopping couple of seconds here. So now I can come back to my Design Study 4, click Result, and there we go. And I can see that I've substantially reduced the deformation by changing those arms to aluminum. And all of this information is saved in the SimSolid study file. So I can come here to Project. I can save my project as, and all of that information is saved in here. All of the parts, all of the different design studies, and all of the different results. So it allows you to do, in this case, in literally a matter of seconds and minutes, 4 different design studies on my part, both structural and with the displacement. I'm sorry, the structural and the modal analysis, and then compare the results between them all. So last but not least, I just want to talk briefly about how to get your hands on this software. If you come to altairuniversity.com, that's kind of our portal for all of our university activities. Excuse me, and you'll see right here at the front, the big old button here, Free Student Edition. If I click on that, it's going to take me to this page right here where I can learn a little bit more about the different products, the limitations that we have on that, or most importantly, come here to the Download Now. And that's going to take me actually to the page where I can fill out the information about the student edition to get it. It's a very simple form here. Just make sure you put your name, the school, the department that you're in, and most importantly, we need you to use your school email address. So I know a lot of people have a school email address, and then they focus primarily on like a Gmail where they get their mail. But having that .edu email address is our way of knowing that you are a student, and you'll get the license. And then it will ask you for Ethernet host. You can click here to get information about how to get that host ID, and that's what we cut the license to. The products that you're going to get, you get access to a large portion of our products: Inspire, OptiStar HyperMesh HyperView. SimSolid, unfortunately, is not part of the student edition. We're working on getting it in there. But if you click SimSolid, it will take you to this right here, where you can get your hands on a free trial license of SimSolid. It is a short-term trial license, but it'll allow you to play around with it. And then you can actually get a full license of the software by getting a sponsorship and coming back up to the Altair University homepage here is where you're going to be able to find out how to get a sponsorship. So if you just come back, come back here to the homepage. I don't know if there's any link directly here on the homepage, but if you come to students, I don't know why my internet is behaving so slowly. But there we are. Under student competitions, you can get a sponsorship through there. And again, the sponsorship is very easy to get as well. It's just a very small form that needs to be filled out. There it is, right there. Very short form. You'll get that, and typically within a few days to a week, we can get you set up with a full sponsorship, full license to all of our products. And we'd love to help you out. Again, I know this wasn't the eFest we were hoping for or expecting, but thanks again to the ASME folks for putting something together and allowing us to meet virtually this year. And look forward to meeting with you all in person in 2021. Please do get your hands on the software, and if you need any assistance with anything, don't hesitate to contact me directly. My email address is eric@altair.com. That's ERIK at Altair, ALTAIR.com. And I'd love to help you get to work with the software and help you with the sponsorship. Best of luck, stay safe to everyone, and thanks for taking the time to listen to our presentation here. Have a wonderful eFest, and we'll see you all again in 2021.
It's raffle time. To win, answer the question in the chat box. ASME eFest staff will manage the chat feature and determine the winner or winners accordingly. Follow and interact with the chat to win.
Hello everyone, my name is Mariela Machado and I'm Program Manager here at Engineering for Change and ASME.
Hi everyone, my name is Rosario Ocampo. I am currently pursuing a Bachelor's of Science in Mechanical Engineering at NYU Tandon, and I am supporting Engineering for Change and Engineering for Global Development at ASME as E4C Core Lead.
And this is why we're here with you today to present to you this program that might be relevant to your interests and future career path. I'm here to speak to you about Engineering for Change. Engineering for Change, or E4C for short, is a knowledge organization, a digital platform, and a global community of over 1 million individuals that believe that engineering can change the world. E4C's mission is to prepare, educate, and activate the international engineering workforce to improve the quality of life of underserved communities worldwide. We do this by providing resources and platforms that accelerate the development and delivery of impactful solutions. Engineering for Change is one of the programs supported by ASME that is focusing on engineering for global development, or engineering for social good. ASME believes that this intersection between engineering and global development is very important and relevant to the engineering sector, now more than ever. And this is why in this next slide, I'm showing you why ASME and Engineering for Change believe this is the case. This slide shows the top 5 reasons why people choose engineering as a career path. And as you can see there, on the top 5, you have social good, which is why E4C and ASME are putting even more resources into this intersection and have decided to launch a new program called E4C Corp. E4C Corp will be hosted at ASME chapters worldwide that brings together all students interested in social innovation or engineering for global development to cultivate indigenous innovation, network, and leverage a community of practitioners locally. E4C Corp aims to convene ASME and E4C members in one geographic region to collaborate and share technical, professional, and personal interests so that we can actually advance the engineering sector to solve the most pressing challenges. And I will pass it now to Rosaura for her to explain a bit more about this initiative and, more importantly, how can you get involved?
Thank you, Mariela. E4C Core Challenges. E4C Core is a student chapter opportunity available to all ASME students, just like HPVC and Old Guard, that allows you to have access to educational resources and networking opportunities and field projects. As a student participant, you will improve on your soft skills valuable to all engineers. You'll have access to networks and get connected to like-minded individuals trying to solve global challenges, and access to various resources available on the E4C platform. This is why ASME and E4C is launching E4C Core Challenge. E4C Core Challenge is geared towards students who are interested in engineering for social good and will require participants to find a solution to a problem in their local community that focuses on one of the 17 Sustainable Development Goals. The importance of this is you are able to document the process, focus on the process and not the actual solution, that will allow you to gain valuable skills for the workforce. The E4C Core Challenge is geared towards students who are interested in engineering for social good and will prompt them to find a solution to a problem in their local community that focuses on one of the 17 Sustainable Development Goals. And documenting this process on finding a solution to their local community is documented in a video, and this will allow you to gain valuable skills for the workforce. This past year, pilot challenges in India and Panama rated their topic reasons for joining the challenge, with number 1 being improving management skills and exploring their interests. Number 2 is applying coursework and skills. They're improving who they are and exploring and applying their skills to find local solutions, and creating something, which is actually creating the video as a team that will allow them to document and show their progress and their solutions. The E4C Core Challenge timeline begins in August, where applications open, and between August and September, you can find a team and find a challenge in your local community. Between September and November, you can begin learning in your online modules and do your field work to actually gather content for your video, which you will submit in December for judging. In January, finalists will be chosen for the live event, which is in February, where finalists will present live at ASME eFest. So get excited, and if you have any questions or would like more information, please email us at info@engineeringforchange.org, or you can email me, rosaura@engineeringforchange.org. Thank you for listening.
Thank you so much, everyone. We're super excited to get you on board on this initiative. So again, we're holding it at a few minutes so that you write down those emails there, and we'll be sharing also in the comments on the YouTube Live. Thank you so much, and have a great day. Bye.
How many of you have used additive manufacturing, or often called 3D printing? The GDP for metal AM is going to increase by 22% before 2020. In the last 5 years, the GDP for metal AM has actually tripled. When I got into metal AM 12, 13 years ago, there were only 3 FDA approved metal AM parts, or even AM parts, period. And as of this May, there are 300 FDA approved metal AM parts. I think it is very, very timely to see how mechanical engineers can position ourselves in this exciting topic. So I went to NC State for my graduate program. I very quickly realized that everything that we learned in material science or in mechanics or in finite element needs to be adopted for additive manufacturing. So I developed an appreciation for powder metallurgy, because the way powder flows is going to affect the way your printer works. I developed an appreciation to how to use different SEM techniques, because that helps me get an understanding of what's going on in the process. It also gave me an opportunity to work with very interesting case studies. For example, we designed and developed the first total knee replacement for a cat in the entire world. The knee replacement was about this small. So it was pretty exciting to work on all these different topics. Everything I do in my lab, or everything I've learned in my lab, I learned an appreciation for how the industry perceives it and how it could be presented as a solution if it is a solution to the industry. So it was a good balance between doing research in the lab, understanding what the industry needs are, where the industry is right now, and whatever we are doing in the lab, could it be used in the next 3 to 5 years? I always say you have to check one or preferably all 3 boxes before you use additive manufacturing. 1, it has to be highly customized design. 2, it has to be highly complex, either the design or the material. 3, you just need a few of them. So how do we look at, as mechanical engineers, how do we look at additive manufacturing? One, I would say this: we have all the tools we need. We understand material selection, we understand the design process, we understand computational evaluation, whether it is FEA, CFD, we understand mechanical testing, we understand fatigue testing, we understand statistical evaluation. But how do we take all of these tools and apply it to a new field like additive manufacturing? I would say this: we have to expand our palette. So FEA by default is not designed for anisotropic behavior. So there we go. If you are working in that particular field, expand your, dig a little deeper in terms of modeling anisotropic behavior. So having said all of this, I do want to caution one thing, which is it is highly dynamic. In the maturity cycle where additive manufacturing is right now, pick one particular aspect of the entire additive manufacturing, for example, design, or for example, materials, or for example, processing or post-processing. Pick one and continue to explore that, because the technology is evolving, the machines are getting better and better. One thing I do is I do go to one particular industry expo on additive manufacturing every year. It's not probably the most robust when it comes to peer reviews, but I still manage to go there by giving one presentation, and I go there just for one day. You know why? I get to see what is the latest software solutions that is being offered. I get to see who are the latest manufacturers. I get to see what is the latest technology. So keep yourself updated, because until in the next 10 to 15 years, when additive manufacturing is fully matured as a plug and play, just like any other advanced manufacturing processes, it is going to be dynamic. So final takeaways that I want to emphasize on. One, it is highly dynamic. Pick 1 or 2 topics that you are specifically passionate about and run with it. Pick something that's fun and exciting, that you are excited, you want to come and work and go to the lab or do something. I said, yeah. And if somebody is willing to pay for it, then that's your job. So pick that one thing that you would do for free and have fun doing it, then that's your job. Thank you.
So the ASME insurance program has been around since 1958. We currently service over 20,000 ASME members. We have 23 different insurance plans, ranging from life insurance, accidental death and dismemberment, auto, home, all the way down to pet insurance. As a young engineer or a self-employed individual looking to branch out and start their own business, one of the most important insurance products to consider is professional liability insurance. That's going to protect what you've worked so hard to build. We offer professional liability insurance through Beasley. Beasley is an A-rated carrier who essentially wrote the book on cyber liability protection. And one thing that's really great about the Beasley professional liability policy is that it has a cyber liability plan that's inclusive to the professional liability policy. It also offers things like webinars, additional resources that you can learn about growing a business and protecting your assets, and of course the Beasley Breach Response Remediation Service, which is the only in-house team that will help mitigate any cyber liability risk that may have occurred. We've got an annual renewable term life insurance plan through New York Life, and additionally, members receive a 25% premium discount. They also receive a 10% discount on their professional liability insurance, and there's also group rates received through our auto home program. Essentially, it pays for itself. If you were to take advantage of some of the insurance programs available to membership, the savings alone would pay for the membership itself. Lastly, I'd like to tell those watching that we do have a call center who can answer any questions they may have. That call center is open 7 days a week. And we also have a website, that's asmeinsurance.com, where you can find additional information on the various products and services we offer, along with applying online.
The ability to have robots that can do maintenance will be advantageous.
And the ability to add autonomy and autonomous features will allow for more high-value application for those robots.
We are in the process of building a diverse portfolio of robotics applications. The first I'll go over is a company by the name of 57 Degrees, and they are in the process of developing a robot that will do QA, surface prep, repair, and then QA the repair on painted surfaces. And the use case that they're looking for is an upstream use case, which is offshore platforms and maintaining the paint coatings on those offshore platforms. I think one of the more interesting cases with that particular company is the fact that the QA on the final paint is actually built into the robot, so that when the robot leaves the area it's doing this repair, you're digitally assured that that repair was effected.
As robots are being designed with articulating arms or features that can be able to work, whether it's a crawling robot or a unmanned aerial system, this will be where more and more robots will be developed for doing maintenance.
And what it really does is it frees up the technician to actually let them focus on the more interesting part of their job versus the part of the job that frankly they might have struggled with in the past. So if we can give them tools that allow them to work on things in a way that they're excited to do, they're generally pretty pleased with that.
ASME has a fair amount of presence in the non-destructive examination with our rules for examining both construction of assets and in-service assets. We also have rules for welding. But I think the outlook would be, in the future, this will be where more and more robots will be developed for doing maintenance.
You will see a shift in the skill set of our workforce that's required to execute some of this work. Typically, the technology companies that understand robotics technology don't necessarily understand exactly what goes on inside a refinery or a chem plant or an upstream production platform. Vice versa, the contractors that do work on our facilities typically do not understand the capabilities of robotics technology. So I think that there's a real opportunity for innovation here to bring these two companies together, and I think we can have a real impact on the industry.
Hello again, this is Aaron Weinerman with ASME Global Public Affairs. I had the opportunity to go to eFest in India a couple months ago, and I met hundreds and hundreds of students, some of whom competed in the very first elevator pitch competition. An elevator pitch is a brief, persuasive speech which should spark interest in what you do or what your organization does. These pitches are essential tools for your interviews or presentations or other talks throughout your career. For eFest Digital, we offered students the option of two different challenge statements, one related to additive manufacturing or 3D printing, and another related to this global COVID-19 pandemic. I'm happy to announce that we have released all of the additive manufacturing elevator pitch videos. You can find them on the elevator pitch playlist. So winners will be announced at the end of the day. Stay tuned and good luck.
Hi everyone, my name is Nida Ahmed and I'm a program manager for the EFX program here at ASME. If you didn't already know, EFX is a type of event within the eFest portfolio. It's a smaller, one-day event held on campus at a college or university in your region. Just like eFest, it brings students together to network and learn from each other and to celebrate engineering. For more information about EFX, email asmeefx@asme.org. Now stay tuned for a session on member resources by my colleague Valentina Alayan.
Hello, eFesters. My name is Valentina Alayan, and I am a strategic project specialist here at ASME. I wanted to welcome you all to our ASME member resources session. In this session, we're going to be talking about accessing your ASME member benefits and then focusing on two major benefits, one of them career-related and the other one academic. The primary point of this session is to show you a little bit more about how you can enhance your member experience and make the most of those ASME dues. To give you guys a little bit more background, I'm going to start off by telling you a little bit more about me. So I actually graduated 2 years ago with a degree in mechanical engineering. I was an ASME student member, starting out being chair and vice chair of my student chapter and actually organizing the first eFest West. And then when I joined staff, I try to bring some of those experiences into my work. So as I'm going through this session, I'm going to try to talk to you guys and put myself back in your shoes, telling you guys a little bit more about how these benefits can help you as a student and as you transition into graduates, and really explain how to make the most of your member benefits. Once you become an ASME member, there are a variety of different ASME member resources and benefits that you're eligible for. Therefore, the first thing that I wanted to talk to you guys about was accessing your benefits. Now, you can do this on your phone, you can do it on your favorite web browser, but the main thing that you need to do to start off is you log into asme.org. So when you open up asme.org, this is the homepage that you're going to see. If you're doing this on mobile, it might look a little bit different, but it's about the same page. Now, there's a lot of different categories and a lot of good information on asme.org, but for the purpose of this presentation, what I really wanted to focus on was talking about your ASME member benefits. If you go on top at the ASME membership tab, you can see the general benefits, but the first thing that we really want to do is get you signed in to use your account. So on your top right corner, you're going to see your sign in, create account button. And what you want to do is you want to make sure that this is signed in so that you can log into your account. Click this. It's going to open up the option to type in your email address, either create a password or submit the password that you have. If you're like me, you're probably going to have this information stored on your computer because you don't remember any of your passwords. And if you need to reset your password, you can always click forgot your password. So once you're here, you click continue. And now you'll see that the next time you're on asme.org in that top right-hand corner, it actually just has your name. So now you know that you're logged into your account, that all of your member benefits are there. Every time you're adding something into your cart, it's going to show up and you're on your ASME account. Click on that and you're going to open up your My Account option. What you want to do is you want to be able to access the ASME member benefits that are available to you. When you open up your My Account page, sometimes you'll be in the account details page. Just right below it, hit Access My Benefits, and this will take you to all your benefits. This page you can scroll through, or you can actually click through it and find out what the benefits fall within each category. So within learning, as you can see, we have ASME conferences, Access Engineering, Learning and Development, and publications, Mechanical Engineering Magazine, that's always a popular one, the Smart Brief, journal discounts, career resources. We have the ASME Career Center and the mentoring program. In networking, we have technical divisions and sections and discounts. So as you guys can see, for the purpose of this presentation, I clicked through these rather quickly. I just wanted to give you guys a taste of what some of the member benefit categories are. But the biggest thing that I want you guys to be able to do is be able to access this page. So log in on your own time and take a look at these member benefits. Make sure that you guys become better acquainted with them. And then if you do realize once you are logged into your My Account page, you can do a variety of different actions. You can update your communication preferences to make sure that you're receiving all the relevant information. You can view your purchase history so you can see every time if you've paid your dues or not. Edit your addresses if you are moving or have moved, especially for my graduating seniors. Please, please, please make sure that your graduating address is the new place you're going to be living and not your old dorm room. And then you can also just access this page and click through your member benefits. So from all of these categories, I know that most of you guys are students or early graduates, so I wanted to take a look at two of the major ASME member benefits that can help you right now. As students, I know that a lot of you guys are looking for internships, either for the summer or for the fall, and sometimes full-time positions if you're graduating or have recently graduated. So the ASME Career Center is your best bet for finding potential job postings and then other resources that can help you in your job search. So once you log into the Career Center, you can access this page, whether it's through the Access My Benefits that I just showed you. You can find it on the asme.org website in the membership page. You can Google it. This is what the homepage of the ASME Career Center looks like. Now, there's a lot of information on this page, so I'm going to go through this in a couple of steps, showing you guys some of the both job search features that it has, and then also some of the additional resources that make it more than a job board, but rather a full-fledged career center.
So the first thing that I wanted to talk to you guys about is the job search feature. So when you're searching for a job, you want to utilize the job search feature first. You can always upload your resume and go from there, but I always recommend starting off with a job search just to get a taste of what jobs are out there. When you're utilizing the job search feature, there's 3 different categories that you can use to narrow down your search. You can utilize keywords. So let's just say you want a certain word in the job title, maybe a company name, maybe a skill. You can always type it into one of those categories and keywords. If you are restricted to location, or if you're not looking to relocate, or if you already know where you want to relocate to, you can always search by location and give yourself a radius. You can find jobs that work remote. There's a huge push for more remote positions being created, especially as you guys know, a lot of people are working remote right now given the circumstances. So that's always something that you can try to factor in. And then there's categories. So when you're logged in, you'll be able to see that a lot of the categories are the different degrees. So there's chemical engineering, computer software engineering, and as you would scroll down, you'd see mechanical engineering and different focuses, whether it's aerospace or manufacturing, and that sort of thing. Now, if you're taking a look at the job search page and you're saying, listen, I don't really know what exactly I'm looking for, whether it's location-wise or whether it was one of the keywords, another way that you can find out more about who's hiring is clicking our Who's Hiring page. So this Who's Hiring page is constantly being updated. So this will allow you to look at specific companies. So if you want to know what companies are hiring today, right now, you can click on there. You can see some of the companies that are hiring and then some of the positions that they're looking for. As you guys can see on there, we don't just have corporate companies that are looking for positions. We also have universities that come and are looking for positions. Sometimes they're looking for professors or department heads, that sort of thing. So the Who's Hiring page is great for if you're trying to see some of the big industry players or some of the companies that are hiring that have posts on our page. So going back to the Career Center homepage, I mentioned earlier that on top of offering job postings, this Career Center is unique in the sense that it offers additional career resources. So you'll see here on top the Career Resources tab. Now these career resources are constantly changing, from YouTube videos to webinars to articles about common topics to other ASME resources that tie into the Career Center. But the one I really wanted to talk to you guys comes up next. So the ASME A Day in the Life webinar series features mechanical engineers working at different companies talking about their experiences, their insights into being an engineer, and you can actually attend these webinars live, and then once they are completed, you can actually go back and watch past webinars. So they're a good way for students and graduating seniors to learn a little bit more about what kinds of jobs they should be applying, what these companies are doing, and then what it's like to really be a mechanical engineer. But before you can become that engineer, you need to graduate and pass all of your classes, which actually brings us into our second major student and early career benefit, Access Engineering. So Access Engineering is a McGraw-Hill resource. As an ASME member, you get free access to it. Now, the Access Engineering page has books, videos, tutorials, charts, case studies, a variety of different resources that you can use in your academic career, and then also for your competition teams, if any of you guys are a part of those. Accessing the website is really easy. Just like I showed you earlier, you go into your My Benefits page and you hit on Access Engineering. You can also do it from the membership page, but you must access it from the ASME page. As you guys can see in that top right corner, it says Access via ASME. So you have to come through the ASME webpage. That way they can verify that you're a paid member. The page itself actually has a variety of different textbooks. It has the Mark's Handbook, as you can see down there, but it also has textbooks outside of engineering, so biology, chemistry, physics. So you'll be able to utilize this resource for a lot of your classes. If you're not necessarily using a McGraw-Hill text in your class, there's a lot of really good supplementary problems, examples on there, and then also practice exams that you can use to prepare. If any of you guys are taking your PE exam or your FE exams, there's some review materials in there that you can access, and really importantly are the SHOMS outlines that are really great in terms of getting a clear picture of a certain topic. In addition to the textbooks, Access Engineering has a variety of different resources that can really make it easy to get through the engineering curriculum. The first of these resources is DataViz. So this will actually let you explore material properties. So when you go into DataViz, there's a tutorial you can watch, there's different projects you can see. But if any of you guys have taken mechanics of materials or any other materials-based classes, definitely utilize DataViz. As far as spreadsheets, a lot of times you are creating your own spreadsheets or writing your own code in MATLAB to complete different equations or find different variables, and there are actually pre-created spreadsheets that come from the textbooks that you can use on here. As far as videos, there's a lot of instructional videos that you can utilize, and then there's also graphs and tables. So a lot of times when you're trying to print whether it's steam tables or whether it's materials tables, instead of having to go looking for the right ones, you can use the charts and tables page, go in there, print out a nice version for you to use on your homework without having to necessarily pull out a full textbook again. So like I mentioned earlier, there are a lot more benefits that come with your ASME membership. So go back to your My Benefits page like I showed you earlier and check those out. I just wanted to focus on the two that you guys could use more frequently as students. But before we finish off this session, I wanted to quickly talk about ASME membership dues. So you pay your ASME membership dues once a year, and they do cover your membership for a full year. The total cost of ASME membership is $158, and you'll actually see that reflected in our professional, fellow, or affiliate rate. However, because we understand that students can't pay that high price, we actually created our student membership. It entitles you to many of the same member benefits, however, at a lower cost. So your first year as a freshman, you actually pay $0. Then every year after that, you pay for regular student membership, which is $25 a year. Then your first year after you graduate, you pay $63. Between your first to second year after graduation, $86, $110, $134, until you reach the point of $158.
Thank you for attending this session, and hopefully you guys learned a little bit more about ASME membership. Have fun at your next session.
PAD's Professional Student Edition is an industry-standard professional printed circuit board, or PCB, design tool. Powered by Mentor's Expedition technology, used by some of the most innovative companies in the world, you'll be able to create everything from the most basic of designs to elaborate industry-worthy boards. Why use this for your classes and projects? PAD's Professional Student Edition is filled with features for a complete full-flow PCB solution aimed at minimizing respins and getting designs completed efficiently. with everything from schematic capture, layout, signal integrity analysis, manufacturing, and 3D modeling, you can be sure you've created the best design before sending it out for production. Who does this really benefit? Engineers of all disciplines. We're seeing PCBs in almost every electronic device today, from cars to garden sprinkler timers, and electrical engineers aren't the only ones involved in the process. With ECAD-MCAD collaboration, we're able to design electronics to fit the 3D characteristics and requirements of our end goal products. So really, electrical and mechanical engineers can work together to produce the perfect design in PADS Professional before sending it out to physical manufacturing. The PADS Professional Student Edition software is simple to obtain. First, go to pads.com and click on Student Edition in the banner. Here, you can find more information, and clicking Download takes you to a form to request the software. A host ID is required to obtain the correct license for the machine you plan to use, and instructions on how to find the proper ID can be found here. Simply continue with your university information and your graduation date, and you'll be on your way to starting the PADS Professional experience. Soon after submitting the form, you'll receive an email with the installation, license, and some resources. Step-by-step instructions can be found to guide you through the PADS Professional Student Edition installer. Note that the license required to run the software is attached to the email as a padspro.dat file. Be sure to save this as stated in Step 3 of the installation instructions. Once you've installed the PADS Professional Student Edition software, you may want to take a moment to familiarize yourself with the tool and start with some helpful tips and exercises. Whether this is going to be your first PCB or you're a PCB expert, or if you're just looking to understand what PCB design really entails, you'll find plenty of helpful tips and exercises in the Quick Start Guide, YouTube, on-demand training, and partquest.com. It's important to note that the on-demand training library is usually a paid service, but it's free for students, so take advantage of your free access with promotion code ODT-PPSE__180 found at the bottom of your email. The Quick Start Guide is located in your C drive under PADS Professional Quick Start VX.2.7. Open up the instruction PDF to reveal a fully outlined lesson plan to create a PCB for a simple design, a blinking LED flasher. This guide provides easily accessible links to YouTube video tutorials for each lesson and detailed step-by-step instructions to teach you how to best navigate the tool. Pictures will also help escort you through the design process, and tips are scattered throughout the guide to help you use the PADS Professional Student Edition as efficiently and effectively as possible for this design and for all your future projects. Each lesson is supplemented by project files back in the Quick Start folder. Each lesson folder holds design files to start each lesson. Here, you'll find schematic files known as PADS Professional Designer.prj files and board layout files, saved as PADS Professional Layout.pcb files. If you're more of a visual learner, you can check out the YouTube playlist with video walkthroughs of each lesson. You'll find similar tips in the videos as were in the Quick Start Guide. Another great resource to help you through the PADS Professional Student Edition software is our on-demand training. As the title suggests, these are videos that you can watch at any time to train yourself on every aspect of the tool. Each critical step of the PCB creation process, whether it's library management, schematic capture, PCB design, etc., is split into chapters with specific subsections. If you're looking into learning about adding connectivity, for example, simply click on the applicable chapter and take a few minutes to review the videos detailing connectivity. Learn about the concept as a whole, or skip to a specific topic, like connecting to a bus or using special components, and you'll be on your way to applying the skills to your design. If you're ever in need of more information, there are also other chapters of similar information linked at the bottom of each page for your convenience. The email you received will also link to partquest.com, another resource, but this one isn't for training purposes. PartQuest is a site which links to your PADS Professional Student Edition software and eases the process of importing parts, with defined symbols and footprints, and updating the bill of materials. After downloading your necessary parts, you can easily import into PADS Professional Student Edition with Tools, Import PartQuest Parts. An even more simple way of adding parts to your design is using PartQuest's drag and drop functionality. Once you find a part you need, just click and drag into PADS Professional Student Edition's search menu. All the part information, including symbol and footprints, transfer straight into Designer. PADS Professional will also hold all your parts in this search menu. Partitioning by component category allows for easy sorting and managing the library. There's no guessing game when it comes to adding parts, with an easy-to-view symbol viewer. In this case, we're looking for a 555 timer to complete our blinking flasher schematic. Searching with special characters like an asterisk makes finding parts easier than ever. Star 555 prompts a search of every component ending in 555. We're able to find and place our part with ease. Connecting and completing the design is just as hassle-free as finding the right component. Connect with abutment or simply click N on your keyboard to change into net mode and connect away. Putting a schematic together or making any adjustments has never been easier. Once your design is ready, take a minute to make sure everything fits in your electrical requirements. Signal integrity analysis is critical when designing PCBs. If the signal isn't behaving as expected, it's better to find out earlier and adjust your design rather than producing a board and finding out that you missed project requirements, or worse, created a board that failed completely. Select a net you'd like to analyze and right-click to open Hyperlink's Line Sim. Here, you can review the models and transmission line characteristics for that selected net. You can even simulate with a powerful oscilloscope. Adjust your oscilloscope to produce fairly realistic results of your signal. Here, you can even model the IC at different speeds to make sure that your design is going to work in all situations. Regardless of how complicated your design is, you'll want to verify before going forward. PADS Professional Designer makes the process simple. Run a graphical rule checker or go ahead and verify to make sure that your design rules are all met. Select the design rule checks, or DRCs, that you'd like to run and see if your schematic meets requirements before moving forward. The next step, laying out your board. With smooth connection between schematic and layout, you can open PADS Professional Student Edition Layout from Designer and create a board with all the information you've used in your schematic capture. Forward annotation allows the information to move forward in the PCB flow to layout. Now you can go to Component Explorer and see all the components you used for your schematic in this project and place as necessary. There's no guessing or confusion since you've now connected layout to schematic. Once everything is placed, it's time to route. PADS Professional Student Edition helps you route in a few ways. Whether you're a routing pro or have never done this before, you'll find some easy, convenient techniques to get the job done right. You can clearly see lines on what needs to be connected and where. You're welcome to route one net at a time, or if you see a pattern of many nets going from one general area to another, sketch routing might be a faster option. Sketch where you'd like your traces to land, and PADS Professional Student Edition uses its advanced technology to route following your sketch and following your assigned design rules. You don't need to be an expert to save time with your PCB. This tool helps where you need it. Once you've routed your entire board, you can take advantage of the fact that PADS Professional Student Edition can provide 3D results. Import mechanical models to get the full physical characteristics of your design. Many file formats are accepted, including step files. Now you can review your design in 3D. The 3D tab shows you the components as they look once they were produced. Review the whole board in 360-degree rotation. Connection between schematic and layout is still accessible. If you click on a part in layout, you'll see it selected in your schematic and vice versa. This communication along the PCB design flow allows you to make changes easily and check in on the design at any point in the PCB design process. As mentioned earlier, PCB design is no longer just for electrical engineers. Even mechanical engineering teams are involved to make a complete project. Take the example of this drill. ECAD-MCAD collaboration, used seamlessly between PAD's Professional Student Edition and NX, or Solid Edge, or really any other major MCAD tool, is used to create a full product design. Within NX, you can see all the mechanical components that go into this design, including a PCB. Back in PAD's Professional Student Edition, you can place components in 3D based on the design allotments in NX. Placing components in this 3D view allows clear visuals of any physical hazards, which might not be as apparent if you're using the layout in 2D mode. Once component placement is complete on the ECAD side, you're able to import this information to NX. Not only can you directly import to MCAD, you can accept or reject changes. Reviewing board, component, area, and hole changes allows both ECAD and MCAD tools to stay synchronized and in strong communication with one another. Changes made in NX will be sent back to PAD's Professional in the same way, with the ability to accept or reject. You've heard it time and time again in your engineering courses. The skills you pick up in college will help guide you in your future careers. We're all striving for the best, so why not start with the best PCB software tools? Stay ahead of the curve by mastering all aspects of the PCB flow, schematic capture, layout, signal integrity analysis, and 3D with the PADS Professional Student Edition, now on pads.com.
It's raffle time. To win, answer the question in the chat box. ASME eFest staff will manage the chat feature and determine the winner or winners accordingly. Follow and interact with the chat to win.
Hi everyone, my name is Steve Aspara and I am the Web Production Manager for ASME.org and all of ASME's web properties. It's my pleasure to announce the launch of the HPVC competition videos on the HPVC playlist. Winners will be announced here at the end of the day.
Hi, my name is Danielle Ritchie. I'm a program manager at Lockheed Martin and part of the eFest steering committee. Welcome to the first ever eFest Digital. Have a great competition.
Hi everybody, it's Brandy Smith again from ASME staff. Now we're going to hear from Brandon Graham, CEO and co-founder of ARC Aeronautics and chair of our Student Leadership Training Committee. He's going to give you a presentation on becoming your own boss.
Hey eFesters, my name's Brandon Graham. I'm a two-time entrepreneur, co-founder and CEO at ARC Aeronautics. We're a New Jersey-based tech startup that helps first responders arrive faster and more informed by sending autonomous drones to emergencies. I'm the current chair of student leader training at ASME, and our mission is to help students like you grow your leadership skill sets so you can translate them into your personal and professional lives. I also work with the largest and most active angel capital investment network in the world called Keiretsu Forum. So why should you listen to me? I have only just graduated, so I feel your pain. I remember what undergrad was like. I've been on both sides of the podium starting companies. I've made a ton of mistakes, and I wish someone told me what I'm about to tell you today 3 years ago. But remember, I'm only one investor, so go seek out more information, triangulate, because everyone approaches this from a unique perspective. This just happens to be mine. So everyone's talking about illness right now. Let me tell you one that I've got. One that's been around, in fact, a lot longer than COVID, and one that's actually helping to fight it. Let's think about the reality of entrepreneurship for a second. This is an occupation where someone will willingly and passionately work 80 hours a week or more, have minimal or non-existent social life, make little to no money, and oh, by the way, 95% of these companies fail. And in the off chance of success, they go and do it all of that again with a new company. That's an illness. This lifestyle is not glamorous. It's not lavish. It's honestly not even fun most of the time. But it is the most rewarding experience I have ever been a part of. And it means that in some small way, I can make the world a better place on my terms. Entrepreneurship is definitely an illness. I've got it. And if you've got it, why don't you go ahead and post in the live chat? So becoming your own boss means a lot of things to a lot of people. It could mean more autonomy in the workplace. It could mean being a part of the gig economy. It could mean starting a business that's a lifestyle business or a side hustle. Even high growth potential scalable startup companies like ARC, for example. But if we're talking purely about the entrepreneurial mindset, meaning you have an idea and you want to take that idea from 0 to 1, you're going to need to know a few things. So first, I want you to know your strengths and find a team that you can trust, that complements your strengths, that has the combined skill set and experience to make it happen. Usually this is like 2 or 3 core other people, and you want to make sure that there's an even mix of people who have both the vision and know how to execute. Very important. So next, you want to have a realistic plan and understand the resources that you're going to need to make this idea come to life. And you can think about that as rings of support. So you've got your core team, then maybe your first employees, mentors and advisors, accelerators or incubators to help your company grow, industry connections and maybe your first customers, and then finally capital, which is woven through that whole system. And let me be clear, raising capital is not the first step of starting a company. And if you don't know why that is, that's completely okay, but just know that you don't want to start until you understand the reason why. So the next thing is I want you guys to be able to think big, but be willing to start small. Use prototypes to communicate your ideas. Collect customer data in surveys and get to really know your customer, know who they are, know what uniquely motivates them and what makes them unique. And then the third part of this think big, smart, start small concept is I want you guys to focus on building momentum and collecting data to show proof that there's something here. And if you can show proof and if you can make people feel that you're on a rocket ship and you're going to the moon, the money will come. Finally, be bold and have an identity. When someone asks you what you do, what do you say? What do you say? And how does that message change depending on who is asking you? But at the end of the day, it all boils down to leadership. And today, leadership is more important than ever, as we all know. Remember, no one is born with knowledge, so don't worry about being 100% better every day. Just try to be 5% better every day. Again, think big, start small. Becoming your own boss is like a journey. It's like going to the gym. It's about showing up, but it's really much more than just showing up. To be an effective leader, you have to care deeply about the people that you work with and your customer. You have to always strive to be a more effective communicator, both as a listener and as a storyteller. You have to seek truth and share it openly. Sometimes that's going to hurt, but you have to do it in order to lean into your problems so you can find solutions instead of letting your problems run your life. And in order to do this, you have to be honest with yourself. One of my favorite books ever is called The Art of War. Sun Tzu, the author, says, "In the midst of chaos, there's also opportunity." So in good times, it's easy to look like a competent leader, but leaders are best defined by how they respond to chaos. So in being honest with yourself, ask yourself, in adversity, in chaos, am I calm, cool, collected, and true to my brand? So finally, all of us are going through an incredibly tough time right now. And if you're feeling defeated or tired, or you just don't have the energy to go on right now, don't give up. Don't give up. Just know to rest. So finally, I just want to leave you with these 5 core things to wrap up with, just to recap what we just talked about. I strongly recommend to evaluate your strengths and find a core team to help you translate these ideas into reality, to help take ideas from 0 to 1. So know your strengths and find a core team. Second, have a realistic plan, something that is believable, something that somebody would see and say, yeah, this could be real, this could happen. Third, think big, start small. I want you to start by thinking big, but be ready to start small. Fourth, be bold and have an identity. Somebody who has a brand, an identity, and we've already talked about this today, is a powerful concept because it says that there's an essence to somebody. And that combined with powerful storytelling is just such an impactful way of being. And it's such an important tool as a leader to be able to tell stories and have a brand behind those. And then finally, just remember, nobody's born with knowledge, and leadership is a muscle. So flex it. If you're inspired by this framework for thinking and you want to learn more, student leader training at ASME is here for you. My contact information is located on the slide below, and I would love to stay in touch and put you in touch with the rest of our team. So I hope you enjoy the rest of this eFest Digital. We're so happy to have you and can't wait to stay in touch and learn more about you. So thanks for listening, and we'll see you next time.
My name is Callie Turgey. I am the Senior Vice President for Student and Early Career Development, SCCD, which plans and organizes different activities and programs like the competition, workshops, and sessions at our ASME eFest. And I really want to take this opportunity to thank our wonderful sponsors, our super staff, and our awesome volunteer members. This couldn't be possible without you. Because students, engineering students, thank you for coming, because we do this all for you. You are the future of our society, the problem solvers for the challenges that we face throughout the world. I want to share with you that no matter what you choose when you graduate from college, be it in the manufacturing field or bioengineering, transportation, communication, power generation, you may have different things that you want to continue to learn. And you can count on ASME to provide that. In fact, our Early Career Engineering Programming Committee has so many different resources packaged under its Future Me brand. Make sure you connect with Future Me. And a lot of the speakers that you'll be hearing are our early career engineers, wanting to share what they have learned with you. So with that, I'll let you enjoy the rest of ASME Digital eFest, and thanks for joining.
Hi again, everyone. One last time, John Falcione, still in my home office, still sporting the scraggly beard. I just want to take a pause for one moment to say a couple of things. The first is that I hope that you really enjoyed this program, and if you need to go back and tell your friends that there's a lot of content on our eFest feed through the YouTube live channel that we have set up, so please promote it. We think it's great content for you to share and go back to again and again. One of the ways that we can provide this tremendous content for you is through the gracious help and support of our sponsors. So foremost, I want to thank the four primary sponsors. The first is Siemens, which is our platinum sponsor, Altair, which is our silver sponsor, and then two supporting sponsors, Mercer and also ComSol. Hope you've enjoyed the program. We'll see you again next time. Thanks again for everything. Keep doing what you're doing, and hope to see you next year face to face.
Hello, everyone, and thank you all for your participation in eFest Digital. I'm so delighted that you were able to take part in our inaugural virtual event. It's encouraging to see so many participants, given what everyone is going through coping with COVID-19. Our lives have changed in such a short period of time, and as engineers, we learn to adapt as we strive to make the world a better place. I've been following your online submissions, and I have to say, I'm really impressed with the creativity of your work. Engineers are truly incredible. As I like to say, some are thinkers, some are doers, and some are both, and we call them engineers. On behalf of myself and all of ASME, thank you for participating in eFest Digital, and I wish you all the best on your lifelong journey in engineering. Thank you.